Welcome to the Deep Dive. Today, we're going to dive into the world of data. I know you're already familiar with it from your work with relational databases, but today we're going beyond the basics. We're going to be exploring why data is becoming so important now, especially for businesses here in India. You ready to uncover some hidden treasures?
Absolutely. It's really amazing how much potential is just sitting there in data.
Yeah,
It's like a gold mine.
I like that analogy, a gold mine in your backyard just waiting to be excavated.
Yeah.
So let's get started with something I've been hearing a lot lately, enterprise data. What does that actually mean? I mean, is it just a fancy way of saying all the data a company has?
You're on the right track, but it's a little bit more nuanced than that. Enterprise data really means all the information a business collects from all kinds of sources. We're talking customer transactions, website interactions, employee records, social media trends, even sensor data from equipment. Think about like a manufacturing setup.
Wow, that is a lot more than just what's in the company's database. Why is this such a big deal now? I mean, haven't businesses always been collecting data?
They have, but the difference now is the scale and the interconnectedness of it all. Especially in India, with the huge growth of digital platforms and mobile usage, the volume of data generated by businesses is it's mind-boggling. And what's really exciting is that with the right tools, you can connect data from all these different departments and these different silos, and you can find patterns and insights that used to be hidden.
Okay, I'm starting to see why this is so important, but how are businesses actually using this data to change the way they work? I get that it's about making better decisions, but can you give me an example?
Sure. Imagine a retail company right here in India, and they want to understand their customers better.
Okay.
They could analyze data from their website, traffic, their purchase history, their social media engagement, all of that, and they can tailor their marketing campaigns, like to specific customer segments. They can optimize their inventory based on demand and make sure that they have the right products available at the right time.
So it's not just about understanding what happened in the past. It's about predicting future trends and making smarter decisions right now.
Exactly. And it goes way beyond retail. Think about healthcare.
Okay.
You could analyze patient data, and that could help personalize treatment plans and predict potential health risks. Or in finance, data analysis can help detect fraud and assess creditworthiness.
The possibilities really are vast. This is all really interesting, but, I keep hearing these buzzwords, the 4 Vs of big data. What are they exactly, and why should we care about them?
These 4 Vs, volume, velocity, variety, and veracity, they're really important because they kind of sum up the key challenges and opportunities of working with data today. So first, volume.
Okay.
We've already talked about the huge amount of data being generated, right?
Yeah.
Businesses need the right tools and strategies to manage all of this information. Otherwise, it's just noise.
Right. That makes sense. What about velocity? Data is being generated incredibly fast these days. How can businesses make sense of all this information coming in all the time?
Yeah, you're right. Velocity is talking about the speed at which data is generated and then processed. So think about real-time stock market data. Social media feeds sensor data from a manufacturing plant. Every millisecond counts. That's where tools like Apache Kafka and Spark Streaming come in.
Okay.
They let businesses analyze data as it's coming in, which lets them make decisions in real time.
So is that like having a finger on the pulse of your business, constantly monitoring and reacting to changes as they happen? Okay, that makes sense. But data comes in so many different forms now. How do businesses handle this variety?
Exactly. We're not just dealing with neat little rows and columns in a database anymore.
Right.
Variety means all those different types of data. So structured data from databases, unstructured text from social media, images, videos, even audio. Businesses need to find ways to make sense of all of these different formats, and that's where data scientists come in. They can use tools for natural language processing or image recognition to pull out the useful information.
It sounds like a lot of effort goes into getting the data ready to be analyzed. But let's say you've managed to gather all this data from different sources. How do you know if it's accurate and reliable? That's where veracity comes in, right?
Exactly. Veracity is all about how accurate and trustworthy the data is. Not all data is created equal.
Right.
Some data is just naturally more reliable than others. Think about like user-generated content. There's always a chance of bias or misinformation. Businesses have to think about the source of their data and if there are any potential biases, especially if it's coming from outside the company.
So before you can even start looking for those golden insights, you need to make sure you're digging in the right place and that you're using the right tools.
That's a great way to put it. Data cleansing and validation are essential. You need to make sure you're working with good, clean, accurate data before you base any decisions on it.
So it sounds like managing and analyzing all this data is a pretty big task. What are some of the key things that businesses should think about when they're building their data infrastructure?
Well, I think it's really tempting to jump into the latest technology, but you really need to start with a good, solid data strategy. Figure out what questions you want to answer with your data, what sources you need to use, and what processes you'll use to make sure your data is good quality and secure.
So it's more about having a clear plan than just throwing technology at the problem.
Exactly. Every business is going to have its own needs and its own challenges. Like a retail company might really want to focus on getting customer insights so they can make better recommendations.
Right.
But a manufacturing company might want to use sensor data to improve their production processes. The technology should support the business goals, not the other way around.
That makes a lot of sense. We can't forget about the human side of all this either. I mean, we're collecting so much data about people. How do we make sure we're doing all of this ethically and responsibly?
That's a really important point. Data privacy and security have to be top priorities. Businesses need to be really clear about how they collect, store, and use data, especially personal information. And they need to make sure they're following all the rules like India's data protection laws.
Right.
It's not just about the law, though. It's also about building trust with your customers.
For sure. So what about the future? What are some of the emerging trends in the world of data that you're excited about?
One area that's really taking off is AI, artificial intelligence. We're seeing it being used to automate data analysis, find patterns that humans might miss, and even make predictions. It's like having a really powerful assistant who can go through all of your data and tell you what's important.
It really does feel like AI is everywhere these days. Sometimes it feels like magic. How does it actually work with data, though? Is it really machines thinking for themselves?
A lot of people think that, but that's not really how it works. AI, especially machine learning, uses algorithms that are trained on huge data sets. These algorithms learn from that data, and then they can use what they've learned to make predictions or decisions. So you could train a machine learning algorithm on customer data, and it could learn how to recommend products to those customers or even predict which customers are likely to leave.
Okay, so it's not about replacing humans. It's more about giving us new tools to make better decisions.
Exactly. Another trend that I'm really interested in is data-driven storytelling. It's not just about the numbers anymore. It's about using data to tell stories that can inform and engage people.
I like that. It's about making data come alive and making it relatable, even for people who aren't data experts.
Yeah, exactly. Think about using charts and graphs and maps to visualize data. It's a great way to make complex information easier to understand and more impactful. Data storytelling is really powerful. You can use it to communicate ideas and create change.
It sounds like the world of data is constantly evolving. What does this mean for our listeners, especially those who are working with data here in India?
I think the most important thing is to start thinking about data in a new way. It's about understanding how powerful data can be, asking good questions, and using data to make smart decisions that can help your business grow.
It almost sounds like everyone needs to understand data now, no matter what industry you're in or what your job is.
I agree. Data is changing the world. It can transform businesses, improve people's lives, and shape the future.
Yep.
People who know how to use data are going to have a real advantage.
Before we go on to see a real-world example of data in action, let's recap some of the important things we've talked about. We started by looking at what enterprise data is and why it's so important now, especially in India, where the digital world is growing so fast.
That's right. And then we talked about the 4 V's of big data: volume, velocity, variety, and veracity.
Right.
Those are the challenges and opportunities that data presents. We talked about how businesses are actually using this data, to personalize their customer experiences, make their operations more efficient, and even predict future trends.
And we talked about data privacy and security and those exciting new trends like artificial intelligence and data-driven storytelling, really bringing data to life.
Exactly. So now, to see how all of this actually works in the real world, let's move on to a company that's using data in a really innovative way.
So you mentioned a real-world example. What company are we talking about today?
Let's take a look at a food delivery service here in India. They're using data in a really cool way.
Okay, I use those apps all the time. What are they doing that's so special?
Well, they're not just connecting people with restaurants. They're using data to create a whole ecosystem that helps everyone.
What do you mean ecosystem? That sounds a bit like that enterprise data idea we were talking about before, bringing everything together.
Yeah, exactly. They're collecting data from restaurants, delivery partners, and customers to learn things that go way beyond just delivering food. For example, they're analyzing data to help restaurants plan their menus better,
Oh, interesting.
using local preferences and seasonal trends.
That's smart. So instead of just offering the same menu all the time, restaurants can use data to offer dishes that people are going to want more at a certain time.
Exactly. And it goes even further than that. They're also using data to get food delivered faster. By analyzing traffic patterns and delivery routes, they can figure out the fastest way to get the food to the customer, and that means fewer delays.
So it's better for the customer and the delivery person.
Right.
This is really cool. It sounds like they're creating a much more personalized and efficient experience for everyone involved.
They are, and it's really working. Customers are happier, they're getting more orders, and the delivery partners are making more money. It just shows you how data can be used to help everyone.
This has been a fantastic deep dive. We've covered so much, from what enterprise data is and why it's so important to the 4 V's of big data and how we manage all this information. We even saw some real-world examples of how businesses are using data to change the way they work and come up with new ideas. Any final thoughts for our listeners before we wrap things up?
I'd say the main thing to remember is that data isn't just about numbers and spreadsheets. It's a powerful tool that we can use to solve problems, create new things, and make the world a better place. And in India, with so much happening in the digital world, understanding data is more important than ever.
If this deep dive got you thinking, make sure to hit that like button, subscribe for more, and share this with your colleagues.
And keep asking questions, keep learning, and keep exploring the amazing world of data.
Until next time, happy data diving. Welcome back to the Deep Dive. Today, we're going to be diving into data lakes. What they are, why they're gaining traction, and how they're really changing things in the data world. You're all familiar with relational databases, so it'll be interesting to explore how data lakes are different from that and why companies are starting to use them more and more.
Yeah, it's a really interesting topic, and it's only becoming more and more important as we see this huge increase in the volume and types of data we have to deal with. So to start, let's imagine a data lake is kind of like a big reservoir. But instead of water, it's full of all kinds of raw data. We're talking structured data, semi-structured data, even unstructured stuff like images and videos, all just hanging out together in their original formats.
So unlike our nice and neat relational databases with all their rows and columns, a data lake is kind of more like an actual lake, a bit more wild and unpredictable.
That's a great analogy. It's not about trying to squeeze everything into tables that are already set up. A data lake just takes the data as is, without needing to define its structure ahead of time. And this is really helpful when you're dealing with data that's changing all the time or coming from lots of different places.
This whole store everything idea is pretty interesting, especially because we see so many companies struggling to manage all the data they're collecting. But haven't we always used relational databases? Why are we seeing this shift now?
Oh, for sure. Relational databases are super powerful tools, and there are still times when they make the most sense. But where they start to struggle is when you need to analyze things like tons and tons of social media posts or sensor data from thousands of devices or customer interactions all over a website. Traditional databases just weren't built for this much variety and this much data, especially when the structure of the data is constantly changing.
So you're saying data lakes are kind of a way to deal with this huge flood of information without getting stuck with rigid structures.
Exactly. Think of it this way. A relational database is like a really well-organized spice rack, perfect when you know exactly what you're making. But a data lake is like a giant pantry. You can keep any ingredient there, whether you have a recipe in mind or not. You might have to dig around a bit, but all the ingredients are there ready for you to use.
That's a great way to put it. And this flexibility seems really relevant today, with all the data coming from things like IoT devices and social media. But how does this store everything idea work in practice? How do you make sure it's usable and doesn't just become a jumbled mess?
That's the real trick, figuring out how to manage and understand all that data inside the lake. It's like having all those ingredients in your pantry. You need the right tools to sort, organize, and analyze them. That's where data lakes use a whole bunch of technologies like Hadoop to store and process all that data Spark, to do large-scale analysis and Elasticsearch to make the data searchable.
So it's like having a team of expert chefs who can take all those raw ingredients and turn them into something amazing.
Exactly. And these insights are what companies are using to get ahead of the competition. Let's look at some examples.
I'd love to. I'm curious to see how companies are using data lakes to solve real-world problems.
For example, in cybersecurity, companies can analyze network traffic logs in real time to find and respond to threats way faster. This data is often unstructured and huge, which makes a data lake a perfect place to analyze it.
That makes a lot of sense. Being able to spot unusual patterns in network activity quickly could be really important for preventing security breaches. What other applications are out there?
Data lakes can also help build a complete view of the customer. By combining things like purchase history, social media activity, browsing behavior, and other data points, companies can really understand their customers, which leads to more personalized marketing and better experiences. Just imagine tailoring your offerings to individual preferences. That's the power of a data lake.
It's like taking down the walls between all those different sources of data and getting a much clearer picture of what your customers want and need. That's got to be super valuable for designing products and services.
Totally. Another area where data lakes are making a big difference is in predictive maintenance. By analyzing sensor data from equipment, companies can actually predict when things might break down and create better maintenance schedules. This means less downtime, things run more smoothly, and they save money. It's all about going from reactive to proactive thanks to the insights they get from the data lake.
Those are some pretty amazing examples. It sounds like data lakes are more than just storage. They're about unleashing the power of data to come up with new ideas and make smarter decisions. But I'm guessing there must be challenges when it comes to managing these massive data repositories.
You're right, there are definitely some challenges. We already talked about needing special tools and technologies to handle all that data, but there's also the issue of data governance, making sure the data is high quality, secure, and follows all the rules and regulations.
It sounds like a whole other deep dive we should do. Maybe we can talk more about that in the next part of our conversation.
Absolutely. Data governance and security are crucial to make data lakes work well and responsibly. But for now, let's stop here. If you found this interesting, be sure to like, share, and subscribe to The Deep Dive for more explorations into the world of technology. We'll be back soon to dig deeper into the tech behind data lakes and how they actually work.
We've talked about what data lakes are and why they're becoming so important, but now I'm really curious about the technical side.
Yeah.
How do these massive data repositories actually work?
That's a great question. It's like looking under the hood of a powerful engine. One of the key parts of a data lake is the data ingestion layer. This is where it all begins.
So this is the process of getting data from all those different sources into the lake itself. But data comes in so many different forms and formats.
Yeah.
How do data lakes handle all that variety?
You're absolutely right. Data ingestion is all about collecting data from a huge range of sources, like databases, applications, social media feeds, sensors, you name it. It's like creating a network of pipelines that channel all this data into the lake.
And are these pipelines just simple data transfers, or is there more to it?
There's definitely more to it than just moving data from one place to another. Data ingestion often involves transforming and enriching the data along the way. Think of it like prepping ingredients for a big meal. You might need to clean, chop, or even combine certain ingredients to get them ready to use.
So it's about making sure the data is in a usable format before it even gets to the lake. That makes sense. But let's talk about the tools and technologies involved. What are some of the key players in this data ingestion process?
One popular tool for real-time data ingestion is Apache Flume. It's designed to handle large amounts of streaming data from various sources and then send it to different destinations.
So if I'm understanding this correctly, Flume is like a traffic controller directing the flow of data into the lake. But what about data that's not streaming? How do we handle big batches of data that need to be imported?
For that kind of batch data ingestion, Apache Scoop is often the go-to tool. It's built specifically for efficiently moving data between relational databases and Hadoop, which is what a lot of data lakes are built on.
Hadoop. That's a name you hear a lot in the big data world. Why is it so important for data lakes?
Hadoop is a powerful framework for storing and processing huge data sets in a distributed way. It's like the foundation of the data lake, providing a vast and reliable storage space. It has two main components: the Hadoop Distributed File System, or HDFS, and the MapReduce programming model.
So HDFS is essentially the storage layer of the data lake, spreading the data across multiple nodes to make sure it's reliable and fault-tolerant.
Exactly. HDFS takes large data sets, breaks them into smaller blocks, and distributes them across multiple servers in a cluster. This ensures data redundancy, meaning that even if one server crashes, the data is safe and can still be accessed. It's all about resilience.
That's super important when you're dealing with so much data.
Right.
But what about actually processing this data? That's where MapReduce comes in, right?
Right. MapReduce gives you a way to process those massive data sets in parallel by dividing the work among all the nodes in the cluster. This makes the analysis much faster and more efficient.
So we have Hadoop handling the storage and processing of data in a distributed way. But we also talked about needing real-time data analysis. How does that fit into the data lake architecture?
That's where Apache Kafka often comes in. It's a high-throughput distributed messaging system specifically designed for handling real-time data streams.
A messaging system. How does that connect to the data lake?
Think of Kafka as a central hub where all the real-time data from Flume and other sources comes together. It acts as a buffer, letting different applications consume and process the data at their own speed.
So it's like a message board where different teams can pick up the information they need in real time without overloading the system.
Exactly. And this real-time processing capability is what enables applications like fraud detection, personalized recommendations, and real-time monitoring and alerts.
It's really interesting to see how all these pieces work together. We have Flim and Squoop for data ingestion, Hadoop for storage and batch processing, and Kafka for real-time streaming. But we still haven't talked about actually analyzing the data. How do we extract insights from all this information?
That's where the real value of a data lake lies. We need the right tools to find the insights hidden within all that data. One of the most popular tools for processing and analyzing data on a large scale is Apache Spark.
Spark. So it's like the data scientist toolkit for exploring and making sense of the data lake.
Got it. Spark is known for its speed and its ability to handle a wide range of data processing tasks, from simple transformations to complex machine learning algorithms.
So Spark helps us understand the data. But what about visualizing it? How do we make those insights understandable and easy to share?
Tools like Apache Zeppelin and Jupyter Notebooks are often used for interactive data exploration and visualization. They provide a user-friendly interface for querying data, creating charts, and sharing your findings.
So Spark for processing and Zeppelin for visualization. But what about search? How do we quickly find specific data within this huge data lake?
That's where Elasticsearch comes in. It's a powerful search and analytics engine built for speed and scale. It lets you run complex searches across enormous data sets and get results almost instantly.
Elasticsearch. I've heard of it before, but I thought it was just for simple keyword searches.
Oh, it's much more than that. Elasticsearch can handle all sorts of data types and complex queries using filters, aggregations, and more. It's like having a supercharged search bar for your data lake.
This is amazing. We've talked about Flume, Hadoop, Kafka, Spark, Zeppelin, and Elasticsearch. It's a pretty impressive ecosystem of tools all working together to make data lakes a reality.
It really is. And with the right expertise, this ecosystem can help organizations get incredible value from their data.
Speaking of expertise, it sounds like managing a data lake requires a lot of different skills. Who are the key people involved in building and maintaining these systems?
You need data engineers who are experts in building and managing the data pipelines and infrastructure. You need data scientists who can develop and use machine learning algorithms to extract insights. And you need data analysts who can turn those insights into actionable business intelligence. It's definitely a team effort that requires a mix of technical and analytical skills.
It sounds like the dream team for the data-driven age. But as you mentioned before, there are challenges too, especially when it comes to managing and governing all this data. Maybe we can talk more about that in the next part of our discussion.
Definitely, data governance, security, and metadata management are essential to ensure that data lakes are used effectively and responsibly. But for now, let's take a break. We'll be back soon to delve deeper into these critical aspects of working with data lakes.
Welcome back to the Deep Dive. We spent some time understanding what data lakes are, how they work, and the tech behind them. But now it's time to talk about something just as important: data governance, security, and metadata management.
Absolutely. Building a successful data lake isn't just about the technology. It's about putting the right processes and controls in place to make sure that data is reliable, secure, and accessible to the people who need it.
So let's start with data governance. What does that actually mean when we're talking about data lakes?
Data governance is all about having clear rules and procedures for how data is managed from beginning to end. From the moment it enters the lake to how it's stored, processed, accessed, and even archived. It's about ensuring data quality consistency and compliance with regulations.
So it's like setting ground rules for the data lake, a structure for responsible management.
Exactly. You can think of it as creating a data constitution. It's there to prevent the lake from becoming a data swamp where information is unreliable, inconsistent, or even impossible to access.
That makes total sense. If everyone is just dumping data in without any guidelines, it could get chaotic really fast.
Yeah.
What are some key things that make for effective data governance in a data lake?
One crucial aspect is figuring out who owns the data and who's accountable for it. Who's making sure specific data sets are accurate and high quality. Another key part is establishing clear policies for data access. Who can access what data and for what purposes? And of course, we can't forget about data quality management. How do we ensure that the data in the lake is accurate, complete, and consistent?
Sounds like data governance is about creating a culture where everyone takes responsibility for data. But what about security? Data lakes often have sensitive information. How do we protect that from unauthorized access and cyber threats?
Security is absolutely essential when it comes to data lakes. We need strong security measures at every level. Things like access control, encryption, data masking, and auditing are all important.
So it's a multi-layered approach to keeping the data safe.
Right. Access control makes sure only the right people can get to specific data sets. Encryption protects the data both when it's being stored and when it's moving. Data masking hides sensitive information, but still keeps the data usable for analysis. And auditing helps track who accessed or changed data and when. It provides a history of what happened.
That's good to know that there are ways to protect sensitive information. We've also talked about metadata management. How does that fit into the whole data lake thing?
Well, metadata is essentially data about data. It gives context and meaning to the information in the lake. For example, metadata might tell you where the data came from, its format, the data schema, and any data quality rules that have been applied to it.
So it's kind of like a detailed index for the data lake, making it easier to search, understand, and use the data the right way.
Precisely. Good metadata management makes it much easier to find data. If someone is looking for something specific in the data lake, well-organized metadata can help them find it fast. It's also important for data lineage tracking, so we can see where data originated and how it's been transformed as it moves through the lake.
Data lineage sounds interesting. Can you tell me more about that?
Let's say you have a data point in your lake that's used to make a really important business decision. Data lineage lets you trace the entire journey of that data point, where it came from, what processes were applied to it, and how it changed along the way. This helps guarantee the data is reliable and trustworthy.
This is like building a family tree for data. You can see its history and how it evolved over time.
I like that analogy. And there are specific tools that can help with metadata management and data lineage tracking in data lakes. One example is Apache Atlas. It's often used in Hadoop-based data lakes.
This has been such an insightful deep dive. We've covered a lot from the basic idea of data lakes to the tech that makes them work, and now the crucial aspects of data governance, security, and metadata management. It's clear that data lakes are complex systems with a lot of potential.
I agree. They represent a real change in how companies manage and use data. And as data keeps growing in volume, variety, and importance, data lakes are going to be more and more essential.
We've covered a lot of ground today. Is there one key takeaway you want our listeners to remember?
I think the most important takeaway is this. A data lake isn't just about the technology itself. It's a journey that takes careful planning the right tech, a commitment to data governance, and a focus on security and metadata management. It's about making data a core part of your company's culture.
That's a really important point. Building a successful data lake is about more than just the tools. It's about having the right mindset and using data to make better decisions and drive innovation.
Absolutely. And if you're listening and you're intrigued by the possibilities of data lakes, I encourage you to explore more height. Dive into the technology experiment and see how you can use the power of data in your own organization.
And don't forget to like, share, and subscribe to The Deep Dive for more explorations of the world of technology. Welcome back to The Deep Dive. Today we're diving into the world of data lakes.
That's right.
Now, if you're listening to this, you're probably already familiar with relational databases, all those neat rows and columns.
Yeah.
But what happens when you have data coming in from everywhere? Websites, social media sensors. How do you handle that kind of volume and variety?
Right.
Well, that's where data lakes come in.
Yeah, think of a data lake as like this massive pool of raw data.
Okay.
It's not like your typical organized database. It's more like a giant reservoir that can hold all kinds of data unstructured. The whole works.
Sounds a bit like a data free-for-all. How do we even start making sense of all that information?
Well, that's where the magic of a data lake's architecture comes in.
Data architecture.
Yeah, it's all about layers.
Layers.
Yeah, each one with a specific job to do.
All right, so let's peel back these layers. What are we looking at here?
So a data lake typically has 4 key layers.
4 key layers.
Ingestion, storage, processing, and search. Each one plays a crucial role in turning that raw data into something you can actually use.
So it's like a data assembly line.
Yeah.
Raw data goes in one end and valuable insights pop out the other.
Exactly.
Love it. Okay, let's start at the beginning with ingestion.
Okay.
How does a data lake eat all this data coming from different sources?
Right. So it's not like we just dump everything in there.
Right.
There are actually some pretty clever tools for that.
Okay, what kind of tools?
2 of the most popular ones are Apache Flume and Apache Scoop.
Apache Flume.
Yeah, and Apache Scoop.
Okay, so what do they do?
So imagine Flume like a pipeline constantly streaming live data into the lake.
Okay, I'm picturing it.
Yeah.
It's like a live feed constantly flowing.
Think of things like website clicks happening in real time.
Got it. So Flume is for that continuous stream of data.
Yeah.
What about Scoop? Where does that fit in?
Well, Scoop is more of a bulk mover.
Okay.
It's really good at shifting large chunks of data, especially from those traditional relational databases you mentioned earlier.
Ah, so Flume handles the constant stream and Scoop takes care of the big data dumps.
Yeah, that's a good way to put it.
Makes sense. But where does all this data actually go once it's inside the lake? Is it just floating around in there?
Not quite.
Okay.
That's where the storage layer comes in.
All right, the storage layer.
And here we use something called the Hadoop Distributed File System, or HDFS for short.
HDFS.
Yeah, it's like the bedrock of our data lake.
Okay, so HDFS is the foundation. The lake bed itself. It sounds pretty heavy duty.
It is. It's designed to store vast amounts of data across multiple servers.
Wow.
Making sure nothing gets lost, and it can handle pretty much whatever we throw at it.
Okay, now we're talking about all kinds of data, right?
Mm-hmm.
From those structured databases to unstructured things like social media posts.
Yeah.
It can handle all of that.
Absolutely.
Wow.
Structured, unstructured, semi-structured HDFS doesn't discriminate.
Great.
It's built to accommodate all kinds of data formats. That's one of the things that makes a data lake so powerful. It's incredibly flexible.
Flexibility is key when you're dealing with so much data coming from so many different sources.
Absolutely.
All right, so we've got data streaming in from everywhere, landing safely in our HDFS lakebed.
Yep.
What happens next? I imagine just storing the data isn't the end goal, right?
You're absolutely right.
Okay.
The next step is where things get really interesting.
Ooh, I like where this is going.
This is the processing layer.
The processing layer.
We need to transform all that raw data into something meaningful.
Okay, so let's dive into that.
Uh-huh.
How do we make sense of all this data? What are the tools we use?
One of the most popular tools for this is Apache Flink.
Okay, Apache Flink. We've heard that name before.
Yeah, it's a really powerful engine.
Okay.
And it can handle both real-time processing, like analyzing website traffic as it happens.
So that's the stream processing we talked about.
Yeah,
Uh-huh.
and it can also handle batch processing.
Which is?
More about crunching through huge data sets.
I see. So Flink is our data workhorse.
Yeah, you could say that.
It sorts through this mountain of data, finds patterns, and helps us understand what it all means.
Exactly. Flink is all about extracting valuable insights from the data, helping us see the forest for the trees.
I like that. Okay, so we've ingested the data, we've stored it securely, and now we're processing it. What's the final step in our data lake journey?
Right. So how do we actually use these insights?
Yeah. How do we get them out of the lake and into the hands of people who need them?
Well, that's where the serving layer comes in.
The serving layer.
It's all about making those processed insights accessible.
Okay, so users, applications, things like that.
Exactly.
So how do we do that?
One popular tool for this is Elasticsearch.
Elasticsearch.
Yeah, imagine it like a search engine for your data lake.
Okay.
It makes finding the specific information you need incredibly quick and easy.
So Elasticsearch is like our data librarian,
Yeah, I like that.
helping us navigate this massive collection of insights.
It makes the data easily searchable and queryable, allowing us to find the exact information we need when we need it.
Now, this is a lot to take in,
It is.
but I'm starting to see how each layer plays a critical role in making the data lake work.
Yeah.
It's like a well-coordinated team, each member contributing to the final goal.
And that's the beauty of it. Each layer works in harmony to transform raw, chaotic data into valuable, actionable insights.
We've covered a lot of ground in this first part of our deep dive.
We have.
And before we move on, if you're enjoying this exploration of data lakes so far, hit that like button and share this episode with your friends.
Yeah, spread the word.
And don't forget to subscribe to The Deep Dive for more insightful explorations into the world of data.
Absolutely.
We'll be back soon with more on data lakes.
See you then. Welcome back to our Data Lake Deep Dive.
All right, so we've explored those 4 key layers: ingestion, storage, processing, and serving.
Yeah, and now we're going to take a closer look at the heart of the system.
Okay.
Yeah, the storage layer.
The storage layer.
And how it manages those massive amounts of information.
Okay, let's get to the bottom of this lake. We know HDFS is the key player here,
Yeah.
but I'm curious about how it handles such massive amounts of data.
Right.
We're talking potentially petabytes of information here, right?
Yeah.
How does it all fit?
So think of HDFS like a supercharged filing system
Okay.
built specifically for big data.
Big data filing system.
Yeah, instead of storing files on a single computer, it spreads them out across a whole cluster of servers.
So it's like taking a giant jigsaw puzzle and splitting the pieces across multiple tables.
That's a great analogy. Each piece is called a block.
A block.
And these blocks are copied and stored on different servers in the cluster.
Oh, I see. So even if one server goes down, the data is still safe and accessible on the other servers?
Exactly. It's all about redundancy and reliability.
Makes sense. So it's like having backups in different locations.
Exactly. If one gets lost, you still have others.
Okay, so how does HDFS manage all these blocks across multiple servers? It must get pretty complex.
It does, but HDFS has two main parts that make it all work.
Two main parts.
The name node and the data node.
Name node and date node. Okay, what do they do?
Think of the name node as the master organizer.
The organizer.
It keeps track of where all the blocks are stored, like a giant directory of the entire system.
So the name node is like the librarian knowing exactly where each piece of data is located.
Precisely. And then you have the data nodes.
Data nodes.
These are the workhorses that actually store the data blocks.
Okay.
They get instructions from the name node on where to store and retrieve blocks.
So the name node is the brain and the data nodes are the brawn.
Exactly. A perfect way to put it.
I'm trying. All right, so walk me through this. When you want to store a file in HDFS, what happens?
Okay, so first that file is broken down into those blocks we talked about.
The blocks.
Yeah. Then the name node figures out which data nodes will store those blocks.
Okay.
And then it replicates those blocks for safety.
So even if data node crashes, you can still access the complete file from the other copies?
Exactly. That's what makes HDFS so reliable for storing important data.
This is making a lot of sense. But how do the name node and the data nodes actually communicate?
Well, it's like a constant heartbeat.
A heartbeat?
Yeah, the data nodes regularly send messages to the name node saying, hey, I'm still here and I'm holding these blocks.
So it's like a constant health check, making sure all the data nodes are up and running.
Precisely. And if a data node goes silent for a while, the name node assumes it's offline and automatically starts replicating those missing blocks on other nodes.
Wow, it's like a self-healing system.
Yeah, it's constantly monitoring itself and adjusting to keep the data safe and accessible.
That's incredible. So HDFS really is built for handling these massive amounts of data.
Absolutely. It's designed to be incredibly reliable and scalable.
Scalable meaning?
Meaning you can simply add more data nodes to the cluster to increase storage and processing power.
So it's a truly future-proof system. You can start small and grow your data lake as your data grows.
Exactly. And that's why HDFS is such a popular choice for organizations building robust and scalable data lakes.
This deep dive into HDFS has been really helpful.
Glad to hear it.
It's fascinating how this system manages to store data across a distributed network. I'm already starting to see how all the pieces of the data lake fit together.
Yeah, it all comes together quite nicely.
But we've only scratched the surface of storage, right? What about actually processing all this data to extract those valuable insights?
That's where the real magic happens. We'll uncover the world of data processing in the next part of our deep dive.
Okay, I'm ready to dive deeper.
Great, we'll explore the tools and techniques that make it all possible.
Before we move on to the processing layer, don't forget to hit that like button if you're enjoying this episode.
Yeah, and be sure to subscribe to the deep dive for more insightful explorations.
We'll be back soon with the exciting conclusion to our data lake adventure.
Welcome back to our data lake journey.
Right, we've seen how the data flows into the lake and how HDFS keeps it safe and sound.
Right, and now we're at the main event, making sense of all that raw data.
Okay, let's get down to business.
Yeah.
We've mentioned Apache Flink before.
Yeah.
It seems to be a key player in this processing layer.
Absolutely. Flink is like our processing powerhouse.
Okay.
It handles both batch processing for those large chunks of data and stream processing for continuous real-time data flows.
So Flink is like our Swiss Army knife for data processing.
Yeah.
Ready for any task we throw at it.
Exactly. Its versatility is one of its greatest strengths.
All right, so when it comes to processing data in a data lake, we often hear about two main architectural approaches.
Right.
Lambda Architecture and Kappa Architecture.
Yeah, have you heard of those before?
I have, but I'm a bit fuzzy on the details.
Okay, no
Could
pressure.
you walk us through them?
Sure. So imagine you're trying to understand customer behavior on a website.
Okay.
The Lambda architecture would use batch processing to analyze all the historical data.
Okay.
Say all the purchases from the past year.
Right. To get a sense of those long-term trends.
Exactly. It gives you that comprehensive view of the past.
Okay.
But at the same time, it would also use stream processing
All right.
to analyze real-time data, like current website clicks.
To see what's happening right now.
Exactly.
Yeah.
So you have both a historical record and a live feed.
That makes sense.
Yeah.
So with Lambda, we're essentially processing the data in two different ways,
Right.
depending on whether it's historical or real-time.
Precisely. Now, the Kappa architecture aims to simplify things
Okay, how so?
by treating all data as a stream,
All data as a stream.
even historical data.
Interesting. So instead of two separate paths, everything is handled as a continuous flow.
Exactly. The idea is to leverage the power of stream processing
Okay.
for all data types
Mm,
and eliminate the complexity of managing separate batch and stream systems.
that's a lot simpler.
Mm.
So which approach is better, Lambda or Kappa?
Well, there's no one-size-fits-all answer.
I figured as much.
It really depends on your specific needs and the nature of your data.
Okay.
Lambda, being the more mature approach,
Yeah.
might be a good fit if you need to handle very large historical data sets.
Okay.
Kappa, on the other hand, offers simplicity
Right.
and can be a great choice if you're mainly dealing with real-time data analysis.
So it's all about choosing the right tool for the job.
Exactly.
And Flink can handle both right.
That's the beauty of Flink. It works seamlessly with both Lambda and Kappa architectures,
Wow, that's impressive.
giving you the flexibility to choose the approach that best suits your needs.
Okay, so we've got our architecture in place.
Okay.
Now, I'm curious about the actual processing that happens.
Okay.
What kind of transformations and analyses are we talking about here?
Well, the possibilities are pretty much endless.
Okay, give me some examples.
Flink provides a rich set of operators that allow you to do all sorts of things. You can filter data based on specific criteria,
Okay.
aggregate it to calculate sums or averages, transform it into new formats,
Okay.
even join multiple data sets together to uncover hidden relationships.
So it's like having a data manipulation toolkit at our fingertips.
Exactly. You can perform complex calculations, extract features, and even apply machine learning algorithms to build predictive models.
That's incredible. We're really turning raw data into a goldmine of valuable information.
And Flink makes it all incredibly fast and efficient,
Hmm.
allowing you to gain insights from your data in real time.
This deep dive into the processing layer has been truly eye-opening. We've seen how Flink plays a crucial role in transforming raw data into valuable knowledge.
And we've only just begun to explore the vast potential of data processing in a data lake.
It's exciting to think about what the future holds as these technologies continue to evolve.
Absolutely. The future of data analytics is bright, and data lakes are at the forefront of this revolution.
Well, this brings us to the end of our data lake deep dive.
It does.
We've journeyed from the shores of ingestion to the depths of storage and the transformative power of the processing layer.
It's been quite a journey.
We've uncovered the key components and explored the architectural approaches that power its insights.
We hope this journey has been as enlightening for you as it has been for us.
We encourage you to continue exploring the world of data lakes.
Right. There's a whole universe of data out there waiting to be discovered.
And don't forget to like, share, and subscribe to the deep dive for more fascinating explorations into the world of data and technology.
Until next time, keep exploring, keep learning, and keep diving deep.
Welcome back, learners. Today, we're diving into something particularly relevant for those of you familiar with relational databases, Lambda architecture for data lakes. Now, considering our audience is largely based in India, where the tech scene is just exploding and companies are building these massive data lakes, I think this deep dive will be especially useful.
It definitely will. Figuring out how to effectively process and analyze the sheer volume of data being generated and stored is a major challenge, and Lambda architecture offers a really elegant way to tackle it.
Okay, so let's unpack this. What exactly is Lambda architecture, and why should anyone building or using data lakes care?
Imagine you have a giant pool of data at your data lake, and you need to extract insights from it. Lambda architecture is like a blueprint for building a system that can handle both historical data, which gives you a long-term perspective, and real-time data, which keeps you up to date on what's happening right now.
So it's about getting the best of both worlds, the big picture and the in-the-moment view. But isn't maintaining two separate pipelines, one for historical data and one for real-time data, incredibly complex?
It can be, but that's where the brilliance of Lambda architecture comes in. It breaks down this complex task into three manageable layers: the batch layer, the speed layer, and the serving layer. Each layer has a specific role, and they work together seamlessly to give you a complete view of your data.
Okay, I'm intrigued. Tell me more about these layers.
Let's start with the batch layer, the foundation of Lambda architecture. This layer handles the heavy lifting of processing all your historical data. Think of it as a meticulous historian, carefully sifting through years of information, crunching numbers, and identifying long-term trends.
So the batch layer is all about accuracy and taking its time to get things just right.
Yeah.
What kind of tools would you use for this layer?
Exactly. For the batch layer, you need a processing framework that can handle massive data sets efficiently. Hadoop, with its distributed file system, HDFS, and its MapReduce processing engine is a common choice. HDFS allows you to store vast amounts of data, and MapReduce breaks down processing tasks into smaller chunks that can be executed in parallel across multiple machines.
But what about insights we need right now, in real time? That's where the speed layer comes in, right?
Absolutely. The speed layer is like the news reporter of your data system, constantly keeping you updated on the latest events. It processes data as it arrives, delivering insights with low latency, even if those insights might be a bit less precise initially.
So the speed layer is about speed and agility, sacrificing a bit of accuracy for immediacy. That makes sense. But wouldn't that lead to conflicts? What happens when the real-time insights from the speed layer differ from the historical analysis done by the batch layer?
That's a great question, and it highlights the need for the third layer, the serving layer.
Ah, the serving layer, the part that brings everything together.
Exactly. The serving layer is like the diplomat of your data system, reconciling the different perspectives from the batch and speed layers, and presenting a unified view of your data.
So if the batch layer says, historically, customers in Mumbai prefer product A, but the speed layer sees a sudden surge in Mumbai customers buying product B, the serving layer figures out how to combine these potentially conflicting insights.
Precisely. It could highlight the emerging trend while still acknowledging the historical preference. This ability to combine real-time trends with long-term patterns is what makes Lambda architecture so powerful.
This is starting to make a lot of sense. I'm really starting to see the value of this layered approach.
And the best part is that you're not limited to specific tools. You can choose the technologies that best fit your needs for each layer. It's all about finding the right combination of tools that can handle your data volume, processing requirements, and the types of insights you want to extract.
So it's more of a blueprint than a rigid set of instructions.
Exactly. The key is to understand the core principles of Lambda architecture and then adapt it to your specific use case.
This is fantastic. We've got a good handle on what Lambda architecture is and why it's important. But I'm curious about how it actually plays out in a real-world scenario. Let's say we have an e-commerce company in India, like Flipkart or Amazon, using Lambda architecture. How would each layer come into play?
Great question. Let's imagine we're trying to understand customer behavior on one of these platforms.
All right, so we've got our massive data lake full of years of customer data purchases, browsing history, .ratings, everything. What's the batch layer doing with all that information?
The batch layer would be analyzing all that historical data to identify patterns and trends. It could tell us things like, what are the most popular product categories? What are the seasonal buying trends? Are there regional differences in purchasing behavior?
So the batch layer is giving us the big picture, the long-term view of customer behavior. But what about the speed layer? What kind of real-time insights would be valuable for an e-commerce company?
The speed layer would be focused on what's happening right now. It would be tracking things like, which products are customers currently viewing? What are they searching for? Are there any sudden spikes in demand for specific products?
So the speed layer is giving us a real-time pulse on customer activity, which is incredibly valuable for things like inventory management, targeted promotions, and even fraud detection.
Absolutely. And then the serving layer comes in to combine these two perspectives.
Okay, I'm really curious about this. Give me an example of how the serving layer would bring together the insights from the batch and speed layers for our e-commerce platform.
Let's say the batch layer has identified that customers who buy a certain brand of smartphone are also likely to purchase a screen protector. Meanwhile, the speed layer sees a customer browsing that specific brand of smartphone right now. The serving layer can combine those insights and trigger a real-time recommendation for a screen protector.
That's a great example. And it really highlights the power of Lambda architecture to deliver personalized experiences, improve customer satisfaction, and ultimately drive sales.
Exactly. And that's just one example. The possibilities are endless when you can combine historical analysis with real-time insights.
This has been incredibly insightful. We've covered a lot of ground in this first part of our deep dive into Lambda architecture. We've talked about the three layers: batch, speed, and serving, and how they work together to provide a unified view of data. We've also touched on how this architecture can be applied in a real-world e-commerce scenario.
And we've only just scratched the surface. There's so much more to explore, especially when it comes to the specific technologies and implementation details for each layer.
We'll definitely be diving deeper into those topics in the next part of our deep dive. But for now, if you're finding this conversation valuable, please hit that like button and subscribe to the channel. We'll be back soon to uncover more of the fascinating world of Lambda architecture.
And before we dive into those details, I think it's crucial to understand why Lambda architecture is particularly relevant for our listeners in India.
Yes, you're right. Why is this architecture so well suited to the Indian tech landscape?
Well, think about the sheer scale and diversity of data generated in India. You have a massive population, rapid digital adoption, and a booming e-commerce sector. That translates to huge volumes of data coming in from various sources at different speeds.
So the challenge is not just volume, but also variety and velocity.
Exactly. And traditional data processing systems often struggle to keep up. That's where Lambda architecture shines. Its layered approach allows you to handle both the high-volume batch processing of historical data and the real-time streaming of incoming data, all within a unified framework.
It's like having a system that can keep pace with the dynamism of the Indian market.
Precisely. It allows companies to make sense of the past, understand the present, and anticipate the future all at the same time.
Okay, I'm even more convinced now that this is a vital topic for our Indian listeners. So let's get back to those layers.
Yeah.
We talked about how the batch layer is like a historian carefully analyzing the past. But how do we actually build this layer? What are some key considerations?
One of the most crucial decisions is choosing the right processing framework for your batch layer. We mentioned Hadoop earlier, and it's definitely a popular option, especially for large-scale data processing. But there are other frameworks like Apache Spark that might be a better fit, depending on your specific needs.
So what factors would you consider when choosing between Hadoop and Spark, for example?
Well, Spark is known for its in-memory processing capabilities, which can make it significantly faster than Hadoop for certain types of analysis. It's also generally easier to use and more versatile. But Hadoop might be a better choice if you're dealing with truly massive data sets, and cost is a major concern.
So the trade-off between speed, ease of use, and cost.
Exactly. And you also need to think about the types of analysis you'll be doing. If you're primarily doing complex queries or machine learning, Spark might be a better fit. If you're doing more straightforward ETL, extract, transform, load operations, Hadoop might be sufficient.
Got it. So it's not just about the size of the data, but also the complexity of the analysis we want to perform. What about data storage? Is that a separate consideration?
It's absolutely crucial. The storage layer is the foundation for both the batch and speed layers. You need a system that can handle both sequential access, which is how the batch layer typically reads through large data sets, and random access, which is essential for the speed layer to quickly access and update data.
Hadoop's distributed file system, HDFS, seems like a natural choice here.
It is a popular choice, especially when combined with Hadoop for processing. But you also have other options like Cassandra, which is a NoSQL database known for its scalability and ability to handle high-volume writes.
So again, it comes down to finding the right tool for the job, considering factors like data volume, access patterns, and the overall architecture of your data lake.
Exactly. And don't forget about data quality. You need to make sure you're feeding the batch layer with clean, consistent data. Otherwise, your analysis will be flawed, no matter how powerful your processing framework is.
Garbage in, garbage out, as they say. So data validation and cleansing are critical steps before we even start processing the data.
Absolutely. The batch layer is about creating a reliable foundation of insights, and that starts with ensuring data quality.
Okay, let's shift gears now and talk about the speed layer, the part of Lambda architecture that keeps us updated on what's happening in real time. What are some of the key things to consider when building this layer?
The speed layer is all about speed and agility. You need a processing framework that can handle a constant stream of data and deliver insights with very low latency. As we mentioned earlier, Apache Flink and Spark streaming are popular choices for this layer.
I remember you mentioned Spark earlier when we were talking about the batch layer.
Yeah.
So Spark can actually be used for both batch and real-time processing.
Yes. That's one of the advantages of Spark. It's a versatile framework that can handle a wide range of processing tasks. But even though you can use Spark for both layers, it's often more efficient to choose specialized tools for each layer.
That makes sense. So for the speed layer, we'd likely choose Flink or Spark streaming. But processing the data is just one part of the equation. How do we actually get that real-time data into the speed layer.
That's where the data ingestion process comes in. You need a reliable pipeline to capture real-time data from various sources and feed it into the speed layer. Apache Kafka is a very popular choice for this task.
I've heard of Kafka. It's a messaging system.
It's more than just a messaging system. It's a distributed streaming platform that's incredibly efficient at handling high-volume, real-time data feeds. Think of it as a central nervous system for your data, receiving signals from various sources and routing them to the right destinations.
So in our e-commerce example, Kafka would be capturing all those user clicks, searches, and purchase events as they happen, and then streaming that data into the speed layer for processing.
Exactly. And it does this with high throughput and low latency, ensuring that your speed layer is always working with the most up-to-date information.
That's impressive. But with so much data flying around, wouldn't it be easy to get overwhelmed or lose track of things?
That's a valid concern, and that's why it's important to think about data partitioning and message delivery guarantees when setting up your speed layer.
Okay, break those down for me. What do those terms mean?
Data partitioning is about dividing the incoming data stream into smaller, more manageable chunks that can be processed in parallel. This makes the processing more efficient and allows the system to scale more easily.
So instead of trying to process the entire fire hose of data at once, we break it down into smaller streams that can be handled by different parts of the system.
Exactly. And message delivery guarantees refer to the level of assurance that Kafka provides about whether a message will be successfully delivered and processed.
So we're not just making sure that the data is processed quickly, but also that we're not losing any crucial information along the way.
Precisely. And Kafka offers different levels of guarantees depending on your needs and the sensitivity of the data.
That makes sense. We wouldn't want to drop a message to mean a missed opportunity for a sale or a security breach. So we've got our fast processing framework, our reliable ingestion pipeline, and we've thought about data partitioning and message delivery guarantees. I think we have a solid grasp of the speed layer now. What about the serving layer? This is where things get really interesting.
The serving layer is where it all comes together. This is where we take the insights from the batch layer and the real-time updates from the speed layer and create a unified view of our data.
And to do this effectively, we need a technology that can handle both batch queries and real-time queries seamlessly.
Exactly. And one technology that excels at this is Elasticsearch. It's a distributed search and analytics engine that's known for its speed, scalability, and flexibility.
So Elasticsearch is like the master chef of our data lake, blending the carefully prepared ingredients from the batch layer with the fresh, in-the-moment flavors from the speed layer.
That's a great analogy. And just like a skilled chef can create a wide variety of dishes from the same ingredients, Elasticsearch can be used to power a diverse range of applications and use cases.
Give me some examples. How would we use Elasticsearch in our e-commerce scenario?
Well, it could power the search functionality on the website, allowing customers to quickly find the products they're looking for. It could also be used to power real-time dashboards, giving business analysts up-to-the-minute insights into sales trends, customer behavior, and inventory levels.
I can see how those applications would be incredibly valuable for an e-commerce company.
Absolutely. And Elasticsearch can also be used to power more advanced features like personalized recommendations, which we talked about earlier. It can even be used for things like fraud detection and security monitoring.
Wow. The possibilities are really impressive. It sounds like Elasticsearch is a key ingredient in a successful Lambda architecture implementation.
It definitely is. And it's just one example of the many powerful technologies that can be used to build a robust and scalable serving layer.
This has been such a fascinating deep dive so far. We've explored the batch and speed layers in detail, and we've started to uncover the power of the serving layer. I'm already feeling much more informed about the potential of Lambda architecture.
And we're not done yet. There are still a few more crucial aspects of Lambda architecture to discuss, especially around data security and governance.
I'm eager to learn more about those.
Yeah.
And for our listeners, if you're enjoying this deep dive, please don't forget to hit that like button and subscribe to the channel. We'll be back soon to finish our exploration of Lambda architecture. All right, we're back for this final part of our deep dive into Lambda architecture. So far, we've explored the batch and speed layers. We started to see how the serving layer brings everything together. But I know there's more to the story, especially when it comes to data security and governance.
You're right. Those are crucial aspects of any data architecture, especially when dealing with sensitive customer information. And in India, with the growing focus on data privacy and regulations like the Personal Data Protection Bill, these considerations become even more important.
Absolutely. So how does Lambda architecture address these concerns?
Well, first of all, securing a data lake built on Lambda architecture is not that different from securing any other data platform. You need a multi-layered approach, starting with perimeter security. This is where technologies like Apache Knox come in.
Okay. Remind me what Apache Knox does again.
Think of Knox as a gatekeeper for your data lake. It sits in front of your data lake, acting as a reverse proxy, and controls access to the various services and data stored within. It enforces authentication and authorization, ensuring that only authorized users and applications can even reach your data.
So Knox is like the first line of defense, making sure that no one can even knock on the door without proper credentials.
Exactly. But once someone's inside, you need to control what they can see and do. That's where Apache Ranger comes in.
Ah, Ranger. That's the one that handles fine-grained access control.
Yeah, precisely. Ranger allows you to define very specific policies about who can access what data, at what level of granularity. You can control access based on user roles, groups, data sensitivity levels, and even the time of day.
So Ranger is like the internal security system, making sure that even authorized users can only access the information they're supposed to. It's like having different levels of security clearance within your data lake.
That's a great way to put it. And together, Knox and Ranger provide a robust security framework for your Lambda architecture.
This makes me think about all the news we hear about data breaches and privacy violations. It seems like companies are constantly struggling to keep their data safe. Does Lambda architecture make it easier or harder to maintain data security?
It doesn't inherently make it easier or harder. The key is to implement security best practices from the outset, regardless of the architecture you're using. And that includes things like encryption, data masking, and regular security audits.
So it's not about the architecture itself, but about how you implement it and the security measures you put in place.
Exactly. Lambda architecture is just a blueprint. It's up to the architects and engineers to build a secure and compliant system.
Okay, that makes sense.
Yeah.
So we've talked about security. What about data governance? Where does that fit into the picture?
Data governance is often overlooked, but it's absolutely crucial for maintaining a healthy data lake, especially one built on Lambda architecture.
What does data governance actually entail in this context?
It's about having a clear set of policies, procedures, and responsibilities for managing the entire lifecycle of data within your data lake. This includes things like defining data ownership, establishing data quality standards, and tracking data lineage.
Data lineage, what's that?
Data lineage is like a family tree for your data. It tells you where the data came from, what transformations it's undergone, and where it's been used. It's crucial for understanding the context and reliability of your data.
I can see how that would be important, especially in a system like Lambda architecture, where data is constantly flowing between different layers and being processed in different ways.
Absolutely. And tools like Apache Atlas can be incredibly helpful for managing data governance in a Lambda architecture. Atlas provides a centralized metadata repository where you can store information about your data, track data lineage, and even implement data quality rules.
So Atlas is like the librarian of our data lake, keeping everything organized and cataloged.
Exactly. It helps ensure that your data lake remains a valuable source of insights, rather than devolving into a chaotic data swamp.
That's a scary thought. No one wants their data lake to become a swamp. So having good data governance practices in place is crucial for avoiding that scenario.
It absolutely is. And it's not just about avoiding problems. Good data governance can actually enhance the value of your data lake by making the data more trustworthy, accessible, and usable.
This has been an incredibly insightful deep dive into Lambda architecture. We've covered a lot of ground, from the core concepts and 3 layers to the importance of security and governance.
We have. And I hope our listeners in India, especially those working with large data lakes, found this discussion valuable.
I'm sure they did. This architecture seems particularly well suited to the challenges and opportunities of the Indian tech landscape. And for anyone who's feeling inspired to learn more, I encourage you to explore the many resources available online, experiment with different technologies, and see how Lambda architecture can help you unlock the full potential of your data.
That's great advice. And remember, this is a constantly evolving field. New technologies and best practices are emerging all the time, so it's important to stay curious and keep learning.
Absolutely. And as always, if you found this deep dive helpful, please hit that like button, subscribe to the channel, and share this episode with your fellow data enthusiasts. We'll be back soon with more fascinating explorations into the world of data and technology. Until then, happy learning. All right, so today we're going to be taking a deep dive into data lakes, specifically how to get data into them. Now, you guys already have a pretty solid understanding of relational databases, so we can kind of skip over the basics there and jump right in.
Yeah, it's a pretty interesting area. If you think about it, we used to rely heavily on things like data warehouses and data marts. But today, it's really all about that data lake.
Right, that central hub for all of our data, raw, processed, you name it, it's going in there. But getting it all in there smoothly, that's the challenge, right? So what are our options when we talk about data ingestion?
So there's really two main approaches we're going to talk about today. Batch and real-time data acquisition. Batch is kind of like a big delivery truck, right? Comes in, unloads tons of data all at once. It's perfect when you're dealing with these large data sets that don't need to be updated constantly.
So like transferring monthly sales figures from a company's database to the data lake.
Exactly. Now, real-time ingestion, that's more like a conveyor belt. Data's flowing in continuously. This is essential when you need immediate insights. So, say, analyzing customer behavior on a website to give them personalized recommendations right then and there.
Interesting. So it's not just about how much data we're moving, but also how quickly we need it. How do we decide which approach is best for a given situation?
Yeah, that's a good question. There are a few factors that kind of play into this. The frequency of data updates, the urgency of the insights you need, and even the complexity of processing that data. If your data is updated infrequently and you can afford to wait for those insights, batch processing is often the most efficient way to go.
But if you need to act on data as it comes in, like in the case of, fraud detection or real-time stock market analysis, then real-time ingestion is the way to go.
Exactly. It's all about finding the right fit for your specific needs.
Okay, so let's say we figured out whether we need batch or real-time. What are some of the tools that actually help us move the data? Are there any favorites that you'd recommend?
Absolutely. For batch processing, Apache Sqoop is a real workhorse. It's designed specifically to move data between relational databases, which you guys are familiar with, and Hadoop, which forms the backbone of many data lakes.
So Sqoop is our go-to for efficiently transferring those big chunks of data from our traditional databases into our data lake.
You got it. It's particularly good at exporting data from RDBMS to HDFS, which is the Hadoop distributed file system. That's where our data lake lives. It can also bring data back from Hadoop to RDBMS, but that's less common when we're talking about data lakes.
Right, that makes sense. We're trying to, build up the data lake, not drain it.
Yeah.
But what about real-time data? How do we ensure that constant stream is flowing in smoothly?
So that's where Apache Flume comes in. It's a really robust tool for collecting and aggregating streaming data from all sorts of sources.
So if Sqoop is our heavy-duty truck, Flume is like a network of pipelines channeling data from all these different sources into the lake.
Yeah, that's a great way to think about it. One of the things that makes Flume so powerful is its reliability. It's built to handle the challenges of that constant data flow, ensuring that even if parts of the system fail, the data keeps moving.
So no data gets lost in transit, even if there's a hiccup along the way.
Yeah.
Sounds pretty critical for time-sensitive applications.
Absolutely. Flume also shines when it comes to scalability. As your data volume grows, Flume can grow with it. Plus, it's highly configurable, so you can tailor it to fit your specific needs, whether you're collecting data from website logs, sensor readings, or social media feeds.
It sounds like both Sqoop and Flume play, really crucial roles in getting data into our data lake. Now, before we move on, a quick reminder to like and subscribe so you don't miss any future deep dives.
We've been talking about getting data into the data lake with tools like Sqoop and Flume, but when it comes to real-time data, there's another piece of the puzzle that we need to consider.
I'm intrigued. What's this missing piece?
All right, so imagine this. You have all these real-time data streams coming in from different sources, right? You need a way to manage and direct that data before it even hits the lake. And that's where Apache Kafka comes in.
Okay, yeah, I've heard of Kafka. But how does it fit into all of this?
Think of Kafka as like the central nervous system of your real-time data pipeline. It acts as a message broker, receiving data from tools like Flume and then distributing it to the appropriate systems within your data lake.
So it's not just storing the data, it's actually routing it, like a traffic controller almost.
Exactly. So it's receiving these high-speed data streams and making sure they reach the right destination, whether that's a processing engine, a storage system, or even another application.
That sounds incredibly powerful. But I imagine handling all that real-time data must come with some challenges. What makes Kafka so well-suited for this task?
So one of Kafka's key strengths is its incredible throughput. It can handle thousands of messages per second with very low latency. So there's very minimal delay between when the data arrives and when it's processed.
And that speed is essential when we're talking about those real-time insights, right?
Right.
But what about reliability? We don't want to lose any data along the way.
You're absolutely right. Data loss is a huge concern, and that's why Kafka is designed with fault tolerance in mind. It replicates data across multiple nodes. So even if one server fails, the data is still safe and accessible.
Oh, yeah, that's good to know. So we've got speed, we've got reliability. What about scalability? As our data volume grows, can Kafka keep up?
Absolutely. Kafka is built to be highly scalable. You can easily add more nodes to the cluster to handle increasing data loads, making it a future-proof solution for these growing data lakes.
So Kafka really sits at the heart of our real-time data pipeline, managing and distributing those high-speed data streams with impressive speed, reliability, and scalability. Sounds like a pretty big game changer for any organization dealing with real-time data.
Yeah, it's really become a core component of modern data architectures, especially those that are focused on real-time analytics and decision-making. By connecting tools like Flume and Kafka to your data lake, you can create a really dynamic system that can handle the ever-increasing volume and velocity of data.
This has been incredibly insightful. Before we wrap up, I want to remind our listeners to hit that like button and subscribe to the channel for more deep dives like this one. So we've talked about the different ways to get data into the data lake, but what about the data itself? What kind of information are we typically putting in there?
Well, you can think of it in terms of structure, right? So you have structured data, like the neat rows and columns you find in traditional databases.
Right, like customer details, sales transactions, that sort of thing.
Exactly. And that data often lives in relational database management systems, or RDBMS. Fairly straightforward to work with. But then we have semi-structured data. It doesn't quite fit into those neat tables, but still has some kind of organization to it.
Okay, so give me an example. What would that look like?
Think about JSON or XML files. They're often used for exchanging data between different systems. They have tags and elements that provide some structure, but they're definitely more flexible than rigid database tables.
Okay, that makes sense. And then, of course, there's a really interesting one, unstructured data. What falls under that umbrella?
Unstructured data, this is where things get really exciting. This is data that doesn't conform to any predefined model. We're talking text documents, emails, social media posts, images, videos, sensor readings, really anything and everything that can be captured digitally.
Wow, so a data lake can hold all of this diverse data, providing a really comprehensive view of an organization. But I imagine analyzing all that unstructured data must be quite the challenge.
It is. It definitely requires specialized tools and techniques to extract meaningful insights from that unstructured mass of information. But that's also where the true power of a data lake lies.
I can see that. It allows you to analyze data that was previously siloed or even ignored, uncover hidden patterns and trends that you might not have even known existed.
Exactly. And those insights can drive innovation, better decision-making, all sorts of things.
This has been an incredible deep dive into the world of data lakes. We've explored the different ways to get data in, the tools we can use, and the types of data we're dealing with. Any final thoughts for our listeners before we wrap up?
I'd just encourage everyone to really think beyond just storing the data. A data lake is not just a static repository. It can be a dynamic, evolving ecosystem that drives real business value.
Great point. So much potential for innovation and discovery out there. A big thank you to all of our listeners for joining us on this journey. If you enjoyed this deep dive, don't forget to like and subscribe to our channel for more fascinating explorations into the world of data. Until next time, happy data laking. All right, let's dive into this. We all know about databases, right? They're the neatly organized filing cabinets of the digital world.
Yeah.
But what happens when you need information to kind of continuously flow between different parts of a system? That's where things get really interesting.
Exactly. Think of it this way. Your database is great for storing information, but sometimes you need data to be shared instantly, like a live feed.
Yeah.
That's where the concept of a messaging layer comes in.
Messaging layer. Is that like a digital courier service or something?
Yeah.
That's a big deal about it.
It's a really clever way to solve a very common problem in large organizations. Information silos. Different departments or systems often end up isolated. It's like each one's an island holding on to their own data.
Oh. Yep.
And that leads to inefficiencies and missed opportunities.
I see.
Yeah.
So it's like breaking down those walls, and getting everyone talking to each other instantly.
Exactly, yeah. A messaging layer acts as a central communication hub, enabling different applications to exchange information in real time. Wow.
This opens up all sorts of possibilities for streamlining processes and making faster, more informed decisions.
So how does this actually work in practice? Can you give me an example? Paint me a picture.
Absolutely. Imagine an e-commerce website. You place an order.
Okay.
The inventory system needs to be updated immediately. The payment gateway needs to process your transaction.
Right.
And the shipping department needs to be notified. A messaging layer ensures all these things happen seamlessly and instantly.
Oh, wow. So it's like a perfectly synchronized dance between different parts of the system, no more delays or waiting for information to trickle down.
Precisely.
That's pretty remarkable. But how do we actually build this messaging layer? What technology makes this magic happen?
That's where Apache Kafka comes in.
Okay.
It's a really powerful open source platform specifically designed for handling real-time data streams.
Mm-hmm.
Think of it as the high-speed rail of the messaging world.
High-speed rail. Okay, I like that. So Kafka is the engine that drives this whole real-time data exchange.
Yes, but how does it actually work? It sounds kind of complex.
It might seem daunting at first, but Kafka's architecture is actually quite elegant.
Okay.
It uses a system of producers, topics, brokers, partitions, and consumers,
Okay.
each playing a specific role in ensuring messages are delivered quickly and reliably.
Whoa, hold on. That's a lot of terms being thrown around.
Is it?
Yeah, can we break those down a bit?
Yeah.
Who are these producers? What are they producing?
Yeah, so think of producers as the sources of data.
Okay.
They could be anything from applications generating logs to sensors collecting data from IoT devices.
Uh-huh.
They send their data, packaged as messages, to specific channels called topics.
Gotcha. So it's like sending different types of mail to different post boxes.
Yeah,
I've got the producers sending their messages, and these topics act like the address labels.
that's a great analogy.
Thanks.
Now, these topics are hosted on special servers called brokers.
Okay.
And this is where things get even more interesting. Each topic is divided into partitions, smaller chunks of data that allow for parallel processing.
Partitions. Why divide the topics up like that? Is it just for organization?
It's much more than just organization.
Okay.
Partitions are the secret sauce behind Kafka's incredible speed and efficiency.
Oh, interesting.
By dividing data streams into smaller pieces, Kafka can handle multiple messages simultaneously,
I see.
boosting performance significantly.
So it's like having multiple lanes on a highway instead of everyone trying to squeeze into a single lane.
Exactly.
That makes perfect sense. Okay, so we've got the producers, the topics, the brokers, and these partitions. But where do the consumers fit into all of this?
The consumers are the applications or systems that need to receive and process this real-time data.
Okay.
They subscribe to specific topics and get a constant stream of messages relevant to their needs.
So if I'm an application tracking website activity, I'd be consumer subscribed to, like a user activity topic, and I'm getting a live feed of all the clicks, page views, and so on. Gotcha.
Yeah.
And Kafka doesn't just deliver the message. It ensures that it's delivered reliably, even if there are, like hiccups along the way.
Yeah.
Hiccups. What kind of hiccups are we talking about here?
Sure.
And how does Kafka handle them?
Well, think about it. In a real-time system, things can go wrong.
Sure.
A server might crash, a network connection could drop,
Right.
or a consumer application might suddenly stop working.
Yeah, that's true. It's the digital world. Things can get messy.
And that's where Kafka's fault tolerance comes in.
Okay.
It replicates data across multiple brokers. So even if one broker goes down,
Right.
the system keeps running smoothly.
Right.
It's like having a backup generator. Even if the power goes out, the lights stay on.
That's reassuring to know.
Yeah.
So even if there's a server meltdown, Kafka makes sure the messages are delivered?
Yeah,
What about when the data volume explodes? Can Kafka keep up with that?
absolutely. Kafka is designed for scalability.
Uh-huh.
If you need to handle more data, you simply add more brokers to the cluster. It's like expanding your delivery fleet to meet growing demand.
I see.
And Kafka can do this horizontally without any downtime.
So no matter how much data comes pouring in, Kafka can scale up to handle it. That's impressive. But are messages ever lost in transit? What about data loss?
That's a crucial question.
Yeah.
It brings us to Kafka's durability. Kafka writes all messages to disk, and these messages are replicated across multiple brokers.
Got it.
So even if a broker fails, the data is safely stored elsewhere.
Okay.
Think of it like saving your work constantly, no accidental deletions.
I like that.
Yeah.
Okay, so we've got fault tolerance, ensuring the system keeps running, scalability to handle growing data volumes,
Yeah.
and durability to prevent data loss. Kafka sounds pretty amazing.
It is.
And we're just getting started.
They are.
Okay, I'm all ears. What's the secret sauce?
It's all about sequential writes.
Oh.
Imagine arranging books on a shelf one by one.
Uh-huh.
Kafka adds messages to the end of each partition in a specific order. This eliminates the need to constantly rearrange data, resulting in incredibly fast write speeds.
So no shuffling around, just adding to the end. Simple, but brilliant.
Yeah.
But does this order matter when consumers read the messages? Do they get them in the same order they were written?
Absolutely. That's one of the key features of Kafka preserving the order of messages.
Okay.
This ensures data integrity and consistency.
Uh-huh.
Each consumer keeps track of its position in the partition, so it knows exactly which messages it has already processed.
Like remembering your page number in a book.
Exactly.
Okay. But what happens if a consumer crashes? Does the entire system come to a halt?
Not at all.
Okay.
Kafka has a mechanism for handling consumer failures gracefully.
Uh-huh.
If a consumer in a group goes down, its responsibility for reading specific partitions is automatically reassigned to other consumers in the group.
So it's a team effort.
Yeah.
Consumers backing each other up.
Yep.
No single point of failure. I'm sensing a pattern here. Fault tolerance seems to be baked into Kafka's DNA.
You've hit the nail on the head. Kafka's creators prioritized reliability and resilience.
Yeah.
And this extends beyond server failures or consumer crashes.
Right.
Kafka can even handle network interruptions gracefully.
How so? What happens to the messages when the connection is flaky?
Kafka producers are designed to buffer messages locally when the connection to the brokers is disrupted.
Okay.
As soon as the connection is restored, these buffered messages are sent to the appropriate topics.
So no messages get lost, even in the midst of network chaos. That's pretty remarkable. But with all these features, Kafka must be quite complex to set up and manage, right?
Actually, that's one of the misconceptions about Kafka.
Oh, really?
Yeah. While it is a powerful system, setting up a basic Kafka cluster is surprisingly straightforward.
Okay.
And once it's running, it's relatively easy to manage, especially with tools like Apache Zookeeper, which helps coordinate the brokers in the cluster.
Okay, that's good to know. So it's not just for tech giants with armies of engineers.
Yeah.
Smaller organizations can also leverage the power of Kafka.
Definitely.
And if I'm in India, where the tech scene is booming, understanding Kafka could give me a competitive edge in this rapidly evolving digital landscape.
For sure. As more and more companies in India embrace digital transformation, the demand for real-time data processing will only continue to grow.
Right.
Kafka is well positioned to play a crucial role in this exciting future.
Okay, I'm starting to grasp the significance of Kafka, and I can see why you're so excited about it.
Yeah.
We've covered a lot of ground here, exploring the inner workings of Kafka and how it handles real-time data streams with incredible efficiency and reliability.
Right.
But before
And
that...
even more to uncover.
Okay.
Remember how we talked about Kafka's ability to handle a variety of use cases?
Yeah.
Let's delve into some real-world examples.
Okay, let's pause right there. We've been geeking out about Kafka's technical marvels.
Yeah.
And I think it's time to ground this in some real-world applications.
Okay.
We'll explore those fascinating use cases when we return for the final part of our Kafka deep dive. Don't miss it.
You're right. We have delved deep into the technicalities of Kafka.
Yeah.
So let's bring it back to reality and explore how this technology is transforming various sectors.
I'm all ears.
Yeah.
Give me some real-world examples.
Yeah.
What kind of problems does Kafka actually solve out there in the wild?
Let's start with something we can all relate to. Online shopping.
Okay.
Imagine you're browsing an e-commerce site,
Uh-huh.
clicking on products,
Yep.
adding things to your cart.
Yeah.
Each action you take generates data.
Right.
Kafka can capture the stream of activity in real time,
Okay.
allowing the company to personalize your shopping experience, offer recommendations,
Yep.
and even detect potentially fraudulent behavior.
So Kafka is behind those eerily accurate product suggestions that seem to know what I want before I even do it. It's a bit spooky,
Yeah.
but also incredibly effective.
Precisely. It's like having a personal shopper who anticipates your needs. But beyond e-commerce,
Okay.
Kafka is making waves in the financial industry as well.
The financial world, that's a high-stakes environment. How does Kafka fit into that picture?
Think about real-time payment processing and fraud detection.
Okay.
These are critical functions that require speed and accuracy.
Yeah.
Kafka can handle the massive volume of transactions flowing through the system,
Uh-huh.
analyzing them for suspicious patterns and triggering alerts instantly.
So Kafka is like a vigilant security guard,
Yes,
constantly monitoring the flow of money and keeping an eye out for anything fishy.
that's a great analogy. And its applications extend far beyond online shopping and finance.
Okay.
Kafka is being used in healthcare, transportation, and even entertainment.
Really?
The possibilities are truly vast.
Give me an example. How is Kafka being used in healthcare? That's a field where real-time insights can make a huge difference.
Absolutely. In healthcare, Kafka can process patient data from various sources in real time.
Okay.
Imagine being able to track vital signs,
Yeah.
lab results,
Fine.
and medication records instantly. This enables faster diagnosis,
Right.
personalized treatment plans,
Yeah.
and ultimately improved patient care.
Wow, that's incredible. It's amazing to see how a technology originally designed for handling website logs has evolved into such a powerful and versatile tool across so many different industries.
It's a testament to the power of open source technology and the brilliant minds who continue to push the boundaries of what's possible.
Yeah.
And as we move towards an increasingly data-driven world,
Right.
the role of technologies like Kafka will only become more significant.
It sounds like learning Kafka is a smart move for anyone working with data,
Yeah,
especially here in India where the tech scene is exploding.
for sure.
What would you say are the key benefits for someone looking to upskill in this area?
Well, for starters, understanding Kafka equips you with a highly sought-after skill set in the current job market.
Okay.
Companies across industries are looking for professionals who can harness the power of real-time data,
Right.
and Kafka expertise puts you ahead of the curve.
It's not just about landing a great job, though, right?
Right.
It's about opening up new possibilities,
Yeah,
innovating,
well,
and creating solutions that have a real-world impact.
absolutely. Kafka empowers you to think differently about data and how it can be used to solve complex problems.
Okay.
It's about building systems that are responsive,
Oh.
intelligent,
Yeah.
and capable of adapting to the ever-changing demands of the digital age.
So it's not just about keeping up with the latest trends. It's about being at the forefront of innovation,
Yes,
especially in a rapidly developing tech hub like India.
precisely. And as we dive deeper into the age of real-time data,
Yeah.
the opportunities for those who understand Kafka are boundless.
Wow.
It's an exciting time to be involved in this field.
Okay, I'm convinced Kafka sounds like a game changer.
Yeah.
But let's bring this back to our listeners.
Okay.
What are some key takeaways for those who are new to the world of messaging and real-time data?
One of the most important things to understand is that Kafka isn't just a niche technology for tech giants.
No.
It's a versatile tool that can be applied to a wide range of problems, from simple data pipelines to complex event-driven architectures.
So it's not just for large organizations with massive data sets.
Right.
Smaller businesses and even individual developers can benefit from Kafka's capabilities.
Absolutely. Kafka's open source nature makes it accessible to everyone.
Okay.
And with the right resources and guidance,
Yeah,
it's surprisingly easy to get started.
that's reassuring to hear. It sounds like there's a lot to learn,
Yeah,
but it's definitely worth the effort.
it is.
What advice would you give to someone who's eager to explore the world of Kafka?
There are tons of great resources available online,
Okay.
including the official Apache Kafka documentation, which is surprisingly comprehensive and beginner-friendly.
Okay.
There are also countless blog posts,
Love that.
tutorials, and even online courses that can help you get up to speed quickly.
And of course, we'll be sure to link to some of those resources in our show notes.
Yes.
But beyond the technical aspects,
Yeah.
what are some of the key concepts or mindsets that someone new to Kafka should embrace?
One important thing to remember is that Kafka is all about thinking in terms of data streams,
Okay.
not static data sets.
Got it.
It's a shift in perspective that can be challenging at first,
Right.
but it opens up a whole new world of possibilities.
It's like moving from a world of still photographs to a world of live video.
Right, exactly.
Everything becomes more dynamic and engaging.
And once you start thinking in terms of data streams,
Yeah.
you'll be amazed at the insights and opportunities that emerge. It's like having a constant pulse on the heartbeat of your business or project.
Okay, I'm feeling inspired. But before we get carried away with all the possibilities,
Yeah.
let's pause here for a moment.
Okay.
We've talked about Kafka's technical capabilities,
Uh-huh.
explored its real-world applications,
Yeah.
and even discussed how it can empower individuals and businesses to innovate and make a difference.
Right.
But there's one crucial aspect we haven't touched on yet.
Oh, really?
Kafka's impact on the tech landscape here in India.
You're right. That's a conversation we need to have. And it's a story that's just beginning to unfold. We'll delve into the exciting world of Kafka in India when we return for the final part of our deep dive. Don't miss it.
All right, we're back. Ready to explore that final frontier you mentioned, Kafka's impact on the tech landscape right here in India.
It really is an exciting story that's unfolding right now. And yeah, it has huge potential to transform the way we do business, develop technology, and even shape our society.
Okay, color me intrigued. Set the stage for me. What's the current landscape of data and tech in India? Where does Kafka fit into all of this?
Well, India is experiencing this unprecedented digital revolution.
Yeah.
We've got a young, tech-savvy population, a rapidly growing startup ecosystem, and a government that's really actively promoting digital initiatives.
Okay, so we've got all the ingredients for a technological explosion, but what's driving this demand for real-time data solutions?
I mean, it's all about speed, efficiency, and innovation. Businesses across all these different industries are recognizing that data can help them make better decisions, personalize experiences, and optimize operations. And they need tools like Kafka to make sense of all this data, like in real time.
Can you give me some specific examples of how Indian companies are leveraging Kafka to, gain a competitive edge?
Absolutely. We're seeing Kafka being adopted across a wide range of sectors, from e-commerce giants like Flipkart and Snapdeal to fintech disruptors like Paytm and PhonePe.
So it's not just limited to those big tech companies.
Yeah.
Smaller startups, even traditional businesses, are all getting on board the Kafka train.
Exactly. Kafka's open source nature and its scalability make it an attractive solution for organizations of all sizes. And, as the adoption of cloud computing continues to accelerate in India, Kafka's cloud native capabilities become even more appealing.
Okay, I'm starting to see the bigger picture here. Kafka isn't just a trendy technology. It's becoming a really integral part of India's digital infrastructure.
That's a great way to put it. And this trend is only going to grow in the coming years, I think. As technologies like AI, machine learning, and the Internet of Things become more common, the need for real-time data processing, well, that's only going to become more critical.
So anyone in India who wants to build a career in tech, mastering Kafka seems like a really smart move.
Yeah, for sure. It's not just about career prospects, though. Understanding Kafka, well, it equips you with a fundamental understanding of how data flows in the modern world. And that's a skill set that will be valuable across industries, like throughout your entire career.
Absolutely. And for businesses, adopting Kafka, it's not just about keeping up with the competition. It's about staying ahead of the curve and unlocking all these new possibilities for innovation and growth.
Exactly. Kafka is a catalyst for digital transformation. It allows organizations to become more agile, data-driven, and responsive to the ever-changing needs of their customers and the market.
Okay, I'm convinced. Kafka is a total game changer, and its impact on the Indian tech landscape, well, that's just getting started. But before we wrap up our deep dive here, I want to bring it back to our listeners.
Of course, yeah.
What are some key takeaways for anyone who's, just curious about Kafka and its potential?
Okay, well, I think one of the most important things to understand is that Kafka isn't just some technology, It's more like a mindset. It's about embracing the power of real-time data and using it to drive innovation, solve those tricky problems, and just create new possibilities.
That's a great point. Kafka is about shifting our thinking from those static data sets to continuous data streams. It's about becoming more agile, more responsive, and more data-driven in everything we do. And for anyone who's a little bit intimidated by the technical aspects of Kafka, remember that there are tons of resources available to help you get started.
Yeah.
From online tutorials to community forums, there's a wealth of information out there.
Definitely. Don't be afraid to experiment and get your hands dirty. The best way to learn Kafka is by doing. Start with a small project, play around with the tools, and don't be afraid to ask for help.
That's great advice.
Yeah.
So to all our listeners out there, whether you're a seasoned tech professional, a budding entrepreneur, or just someone who's curious about the future of data, we encourage you to explore the world of Kafka.
For sure.
It's a journey that will challenge you, inspire you, and ultimately empower you to make a difference in the world. And as India continues to lead the way in digital innovation, Kafka will play a pivotal role in shaping our future.
It will.
Well said. And on that inspiring note, we've come to the end of our deep dive into the world of Apache Kafka. We hope you found this episode informative, engaging, and maybe even a little bit mind-blowing.
If you enjoyed this episode, please don't forget to like, share, and subscribe to our channel so you don't miss out on future deep dives into the world of technology and innovation.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with data. And remember, the future is real time, and Kafka is your ticket to ride. Okay, so imagine being able to analyze data as it's generated. No more waiting for those overnight batch jobs.
Right.
We're talking about the power of real-time stream processing. And that's what we're diving deep into today,
Yeah.
Apache Flink.
Okay.
This deep dive is, well, it's really perfect for anyone who's familiar with relational databases. So we're going to unpack Flink together and I think really try to demystify the difference between these two things, batch and stream processing.
Sounds good. Let's get started.
Okay, so first things first, what exactly is Apache Flink? Like, how does it even manage to process data in near real time? It almost sounds like magic to me.
Well, you can think of Apache Flink as like a super efficient data pipeline. It's capable of handling both batch processing and stream processing.
Okay.
Data flows in continuously from all these different sources, like databases, sensors, even websites. And it gets transformed and analyzed on the fly.
So it's like constantly working, like a data conveyor belt?
Exactly. And to make this real-time processing possible, Flink relies on, well, two key components. First, you've got the job manager. You can think of this as the brains of the operation. It coordinates tasks and ensures everything runs smoothly, even if there's like a system hiccup, a failure.
Right.
Then you have the task managers, and these are like the worker bees. They execute the data processing across different nodes.
Okay.
And by distributing the work, Flink can handle like massive amounts of data in parallel.
That makes sense, but how does it actually make sense of this never-ending flow of data? I mean, analyzing a continuous stream, that sounds pretty challenging.
Yeah, it definitely is. But that's where this concept of windowing comes in. It's a technique that Flink uses to, well, analyze data in like manageable chunks, even within a continuous stream. So imagine taking snapshots of the data flow at regular intervals.
Okay.
That's essentially how Flink breaks down the stream for processing.
Interesting. So Flink isn't just about moving data around. It actually helps you make sense of it. And I know we talked about Flink having some really impressive data transformation capabilities. Can you tell me a little more about those?
Absolutely. Flink has a rich set of, well, what we call operators. You can think of them like specialized functions.
Okay.
These operators enable a lot of powerful data transformations, like filtering, aggregating, joining pretty much any transformation you can think of. Flink can handle it.
So it's like a specialized toolbox designed specifically for manipulating data and extracting insights.
Exactly. And to make things even more impressive, Flink has these specialized libraries.
Oh, well.
And they're tailored for different use cases. For example, there's Jelly. And Jelly is really good at graph processing. So imagine mapping out relationships in a social network.
Gotcha.
Or analyzing connections between websites.
Yeah.
Jelly would be the go-to tool for that.
That's super useful these days. I mean, understanding relationships is so important in so many different fields. Yeah, absolutely.
Are there other specialized libraries that stand out to you?
Yeah, there's also FlinkML. And FlinkML allows you to perform, like machine learning on real-time data.
Okay.
So think about things like detecting fraudulent transactions as they happen, or personalizing recommendations based on user behavior.
Yeah, in real time.
Yeah, exactly. That's the kind of power that FlinkML brings to the table.
Wow. I mean, to be able to analyze data and learn from it in real time, that sounds revolutionary.
Yeah, it's pretty powerful stuff.
And then we have FlinkSAP.
Right. And this one is designed specifically for what we call complex event processing.
Okay.
So think about detecting patterns in financial transactions.
Gotcha.
Or identifying, unusual website activity as it occurs.
So this one's really important when every second counts.
Right. FlinkSAP can be a game changer in those situations.
Okay, I'm starting to see how powerful and efficient Flink can be. But I'm a little curious about something.
Yeah.
We keep talking about stream processing.
But how is that different from the batch processing that I'm used to with relational databases? Is it just about speed?
That's a great question. And while speed is definitely a major factor, the difference actually goes a little deeper than that.
Okay.
How about I illustrate it with a simple analogy?
I love a good analogy.
Yeah.
Always makes things easier to understand.
Okay, so imagine batch processing as, cooking a large pot of maybe biryani.
Okay, I like where this is going.
You gather all your ingredients, right? That's the data in this case. You cook them all at once. And finally, after a while, you have your, delicious meal. The result.
So you get the outcome, but it takes time.
Exactly. Now, picture stream processing, like making dosa. You add ingredients continuously and cook them as they arrive on the hot tava.
Okay.
You don't wait for a big batch to accumulate. You're constantly producing and enjoying those hot, fresh dosas in real time. Those are the results.
It's a continuous flow and instant feedback.
Precisely. And to really break it down, Let's look at some key differences, maybe in like a table format.
I like that. A comparison table. Those are always helpful.
Okay, so with batch processing, you're dealing with what we call finite data sets. The data is like bounded.
Okay.
The processing happens with a delay, and the latency is high. This approach is good for things like, reports or data transformations that can happen offline.
So batch processing is like that carefully planned meal.
Right.
Prepared in advance.
Now, in stream processing, the data input is a continuous stream. It's unbounded, constantly flowing.
Okay.
The processing happens in real time, and the latency is low. This makes it ideal for things like detecting fraud, generating those real-time dashboards, or anything that needs immediate insights.
So stream processing is like cooking live,
Exactly.
reacting as the ingredients come in.
That's a great way to put it.
That's fascinating.
And here's where Flink is really cool. It kind of blurs the lines between these two approaches. It treats batch data as a bounded stream. So essentially, it provides a unified platform for both types of processing.
So I'm not limited to one or the other with Flink. I can handle different types of data and different processing needs.
Exactly. That's one of the biggest strengths of Flink. It's really versatile. It gives you the tools to unlock insights from your data, whether it's a continuous stream or a finite data set, in real time.
It's like having a universal data processing engine.
Yeah, that's a great way to think about it.
Flink is pretty impressive. And this is just the beginning, right? We haven't even talked about how it achieves those high speeds or its fault tolerance or how it integrates with other big data technologies.
Right. There's a lot more to explore.
Yeah, well, this has been really insightful. And I think we've given our listeners a good foundation to understand Apache Flink and what it can do.
Definitely. This is just the tip of the iceberg when it comes to real-time data processing.
And speaking of diving deeper, don't forget to like, share, and subscribe to The Deep Dive so you don't miss the rest of our exploration of Apache Flink.
We'll be back soon with even more insights about this game-changing technology.
Welcome back to The Deep Dive. We're continuing our exploration of Apache Flink.
Ready to dive back in?
Absolutely. Last time we talked about how versatile Flink is, like how it can handle both batch and stream processing. But now I'm kind of wondering how Flink fits into the bigger picture of data management.
Right.
Is it just a standalone tool, or does it have like a role in more complex systems?
That's a great question. And, Flink isn't just a standalone tool. It's actually a really important component in building modern data architectures. Think about the concept of a data lake, like a huge repository of data from all these different sources, both structured and unstructured data.
Okay.
Flink can be used to ingest data into the lake, process it in real time,
right,
and even feed it into other systems for, further analysis or action.
So it acts like a bridge between different parts of a data ecosystem.
Exactly. And that connectivity is another really strong point of Flink. It can connect to so many different data sources, from traditional databases to, modern messaging systems, even cloud storage.
Wow.
It's like having this universal adapter that can just handle any data format you throw at it.
I mean, that kind of versatility is crucial, especially these days. We're dealing with data from everywhere and in every format imaginable.
Right.
So it sounds like Flink would be incredibly valuable when it comes to building a data lake that's, comprehensive and efficient.
It really is. And, it's not just about ingesting the data. Flink can also be used to, actually process and analyze the data that's already within the lake, providing those real-time insights that, can inform decision-making.
So it's helping organizations to really get more value out of their data lakes.
Right.
Making the data more accessible and actionable.
Exactly. Flink can help break down those data silos that a lot of organizations struggle with, allowing them to get a more holistic view of their operations. And by providing those real-time insights, it empowers them to, make faster and more informed decisions.
I'm starting to see how Flink is more than just, a stream processing framework.
Yeah.
It's actually a tool that can make data more dynamic and responsive.
Exactly. And there's another aspect we should talk about. Flink's ability to handle both batch and stream processing. It makes it a really great choice for implementing what's called the Lambda architecture.
Okay, Lambda architecture. I've heard that term before, but I'm not totally sure what it means.
Sure. The Lambda architecture is this design pattern for data systems.
Okay.
And it aims to, kind of balance the need for both real-time and batch processing.
Okay.
It combines this speed layer for real-time insights and a batch layer for more comprehensive analysis.
So it's like a two-pronged approach to data processing.
Exactly. You get the best of both worlds.
Exactly. You get the best of both worlds.
But how does Flink fit into all of this? Well, Flink is pretty unique because it can actually handle both of those layers, both the speed layer and the batch layer.
Okay.
It's like having this one tool that can do the quick calculations and the deep analysis.
So Flink can be like the unified processing engine for the entire Lambda architecture.
Exactly. And that makes Flink really attractive for companies that, are looking to implement this type of architecture. It simplifies everything by reducing the number of tools and technologies they need.
This is amazing. It's clear that Flink is so much more than just, stream processing.
Mm-hmm.
It's really versatile and powerful. It can play such a central role in building these modern data architectures.
Absolutely. And we've only just scratched the surface. We haven't even talked about some of the, advanced capabilities like its support for machine learning and complex event processing. There's a lot more to discover.
It sounds like it.
Yeah.
Well, this has given me a lot to think about. I'm excited to see how all of this translates into real-world applications.
Yeah, that's exactly what we'll be diving into next. We'll explore how companies are using Flink to, make those faster data-driven decisions and really gain a competitive edge.
I can't wait for that. But before we move on to those real-world examples, let's remind everyone to, like, share, and subscribe to The Deep Dive.
Yes, please do.
We're bringing you these personalized insights to help you stay ahead in the world of data.
Be sure to join us for the final part of our Flink exploration. It's going to be good.
Welcome back to The Deep Dive. We've covered so much ground already, exploring the ins and outs of Apache Flink, its architecture, its versatility, how it fits into that bigger data landscape. But now it's time to get practical. Let's see Flink in action, those real-world scenarios where it's making a real difference.
I'm excited to bring those real-world examples to life.
Me too. So in the last part, we talked about Flink being great at both batch and stream processing, making it perfect for this fast-paced data world. Let's see how those concepts translate into, tangible results. Where is Flink really shining?
One area where Flink is truly revolutionizing things is fraud detection. Its ability to process data in real time, it's a game changer. It allows businesses to spot those suspicious transactions as they happen, prevent those losses before they even have a chance to escalate.
That's so important, especially in industries like finance and e-commerce.
Yeah.
Every second counts.
Exactly. Imagine Flink analyzing this continuous stream of transactions, constantly looking for patterns that just deviate from the norm. Let's say there's a sudden spike in transactions from a particular location or a series of purchases that seem, out of character for a specific user. Flink can pick up on those anomalies in real time, immediately, and then it can alert security teams to, take action.
So it's like a super alert security guard,
Mm-hmm.
always on duty, monitoring for any hint of suspicious activity.
A very apt analogy. And it's not just about reacting to potential fraud after the fact. You can also use Flink proactively, to actually prevent fraud by implementing real-time risk scoring models. These models can assess the risk of each transaction, based on all sorts of factors. That gives businesses the information they need to make, smart decisions about approvals.
That's incredible. So it's like a personalized risk assessment for every transaction,
Mm-hmm.
helping to minimize those potential losses before they even happen.
Exactly.
Are there other areas where we're seeing this kind of impact?
Definitely. Another area where Flink is making a splash is personalized recommendations. Think about those suggestions you see on, platforms like Netflix or Amazon. You might also like recommendations that, sometimes seem to know you better than you know yourself.
Oh, absolutely. Those recommendations can be surprisingly accurate sometimes.
Right. That's the power of real-time data processing in action. Flink can analyze, all kinds of things, your browsing history, past purchases, even your current activity, and use that to generate recommendations that are tailored just for you.
So it's not just recommending products that I've shown interest in before, but it's actually anticipating my needs and suggesting things I might not even know I want.
Exactly. And Flink can take it a step further by even incorporating real-time events into those recommendations. Imagine getting a suggestion for a warm jacket just as a cold front moves into your area, or a recommendation for a specific restaurant because it's offering a limited time discount.
That's amazing. It's like having this personal assistant who knows my preferences, anticipates my needs, and keeps track of all the best deals and events happening around me.
That's a great way to put it. And these applications extend way beyond just shopping and entertainment. Flink can be used for so much more, from personalizing content and learning materials to even healthcare recommendations.
Wow. So it's really about using real-time data to create those hyper-personalized experiences. That's fascinating.
Precisely. And as the amount of data we generate keeps growing, well, the possibilities for this kind of personalization just become more and more exciting.
It really does feel like we're just scratching the surface of what's possible. As we wrap up this deep dive into Apache Flink, what's the one key takeaway you want our listeners to remember?
I think the most important thing is to understand that real-time data processing, it's not a luxury anymore. It's essential. In this fast-paced, data-driven world, businesses need to analyze and react to information instantly. Apache Flink is a powerful tool that can help them do just that.
Couldn't have said it better myself. Flink really showcases how far data processing has come, allowing us to transform that constant influx of information into, well, actual usable intelligence.
And remember, this is just the beginning. The possibilities with real-time data are truly limitless, especially as new technologies emerge.
It's definitely an exciting time to be working with data. A huge thank you to our expert for guiding us through this deep dive into Apache Flink. To our listeners, don't forget to like, share, and subscribe to The Deep Dive for more deep dives into the world of technology and data science.
Until next time, keep diving deep.
And keep those data insights flowing. Okay, so let's dive right into this. I think we're all pretty familiar with relational databases, right?
Yeah.
Those nice organized tables holding all that structured data. But when we think about it, like especially here in India, with our huge digital footprint these days, I mean, the data sets we're seeing are massive.
Yeah.
So where does all that processed data actually go?
Yeah.
When it's, maybe not so neatly fitting into those tables.
That's where data lakes come in.
Okay.
It's like, imagine this massive, super flexible reservoir that can hold, well, not just structured data, but semi-structured and unstructured data too.
So it's not just like a giant data dump.
Yeah.
There's like a system
Absolutely.
for managing it all.
Data lakes, they're really designed to address those challenges, like information silos and needing to handle, well, all sorts of different data formats.
Yeah, because you've got the structured data in the databases.
Exactly.
Then there's like emails and chats and documents.
Yeah, that's semi-structured.
So that's structured, okay.
And then you have images, videos, audio files, just free-flowing text.
So all unstructured.
Unstructured data.
Gotcha.
Data lakes can handle all of that.
So it really is like a one-stop shop, basically, for all your data needs.
Pretty much.
But how do you actually store and manage all of that information efficiently within a data lake?
That's where Apache Hadoop
Okay.
and its distributed file system, which is called HDFS,
Okay.
those come into play. Think of Hadoop,
Okay.
like the engine behind a lot of these data lakes.
Right.
And HDFS is like the really smart filing system
Okay.
that Hadoop uses to organize everything.
Hadoop. I feel like I've heard that name before.
Yeah.
It's open source, right?
It is, yeah.
With a big community behind it.
Huge community supporting it,
Okay.
making it reliable, scalable, just a wealth of knowledge and support available.
Got it. So how does this HDFS actually work?
Okay, so
How does it break down the storage of these massive data sets?
it uses this master-slave architecture.
Okay.
So the master, it's called the name node.
Okay.
And that keeps track of all the data, what it is and where it's located, across the data lake.
Right.
Then you have the workers, which are called the data nodes, and they're the ones actually storing the data in blocks across multiple machines. This distributed approach is really key to HDFS's efficiency.
Storing data in blocks.
Right.
So is that like dividing a large file into smaller chunks and then spreading them out across different machines?
Precisely.
Okay.
And those blocks are actually surprisingly large.
Oh, really?
Yeah, they're 64 millibit by default, but the system's flexible.
Okay.
So you can adjust that size based on what you need.
So Hadoop breaks down the data, spreads it out, and that's how it gets this distributed storage.
Exactly.
Making it, well, I guess, more manageable.
It is, and that distribution isn't just about storage. It's also key for actually processing all that data.
Okay.
Hadoop uses what's called a paradigm. It's called MapReduce.
Okay.
And it breaks down processing tasks and then distributes them across the data nodes,
Okay.
allowing for something called parallel processing.
Parallel processing. So like working on multiple parts of the data like at the same time.
Exactly.
Okay. That sounds really efficient.
It is very efficient.
Can you give me an example?
Sure.
Like how that might work in a real world scenario?
Imagine you've got this huge data set of customer transactions from all across India.
Yeah.
With MapReduce, you could actually analyze purchasing patterns by region, simultaneously processing data from all the different states to get well, a complete picture, much faster than if you were using traditional methods.
Okay.
Yeah.
So Hadoop isn't just about storing the data.
No.
It's also a powerful processing engine.
It is. It is.
This is really making me appreciate
Yeah.
just how complex managing big data actually is.
It's a fascinating field for sure. And
Yeah.
there are even more features
Okay.
that make HDFS so good at managing all this data.
Okay.
Let's talk about replication.
Okay.
HDFS makes copies of those data blocks
Right.
and stores them on multiple data nodes.
So it's like having backup copies just in case one machine fails.
Exactly. Data loss can be a major setback.
Yeah.
And replication ensures that even if one machine goes down,
Right.
the data's still safe, it's still accessible.
Makes sense, especially
Yeah.
when you're dealing with such massive amounts of data.
Right, right.
Okay, that makes perfect sense.
Yeah.
So we've got the data spread out.
Yeah.
We've got backups in case something goes wrong.
Yep.
What else contributes to HDFS's efficiency?
Another key factor is something called data locality.
Data locality.
Hadoop tries to process data
Wait.
on the same data node where it's already stored,
Okay.
which minimizes that data transfer across the network, which can be a major bottleneck.
So it's like processing the data right where it lives, basically, so you don't have to move it around.
Exactly.
Okay.
And then finally, we have something called horizontal scalability, which means you can easily add more data nodes
Oh,
to the cluster as your data grows
Yeah.
without having to overhaul the whole system.
so it's like adding more shelves to a bookcase
Precisely.
as your collection grows.
Exactly.
Okay.
And this scalability is one of the key reasons why Hadoop and HDFS are so popular
Yeah.
for managing the ever-growing volumes of data that we see today.
This is really starting to paint a clear picture in my mind of how data lakes work.
Yeah.
But I'm curious, what does all of this mean for, the average person?
Mm-hmm.
Why should we care
Right.
about data lakes and how they function?
Well, think about how much data is being generated every single day,
Yeah.
not just by businesses,
Right.
but by individuals, you and me.
Yeah, that's true. I never really think about how much data I'm generating
Right.
on a daily basis.
It's a lot, right?
Yeah.
Our online activity, social media interactions, even our fitness trackers.
Oh, yeah.
It's all generating data.
Wow.
And that data can be incredibly valuable
Yeah.
if you know how to manage and analyze it. Data lakes play a crucial role in this process, allowing us to store and analyze those vast amounts
Yeah.
to gain insights,
Right.
make better decisions,
Yeah.
and even personalize experiences.
So data lakes are like the key to unlocking
I'd say so.
the potential of all of that data.
Yeah.
That's fascinating.
Yeah.
This deep dive has been really insightful so far.
It is. Good.
I feel like I've gained a whole new perspective
Yeah.
on the power of data
Yeah.
and how it's managed. But I have a feeling we've only just, scratched the surface here.
You're absolutely right. There's so much more to explore.
Oh, okay.
We haven't even touched on the different tools and techniques used to analyze the data within a data lake.
Right.
Or, the challenges and considerations of data governance.
I'm already eager to learn more. But before we move on, I want to remind our listeners to like, share, and subscribe to the deep dive
Good idea.
for more insightful explorations into the world of data.
Absolutely.
Now let's continue our deep dive into the world of data lakes.
Okay.
We've covered the basics of storage.
Right.
But what about the other technologies that play a role in making these data lakes actually work?
That's a great question. Let's talk about Apache Kafka,
Okay.
a technology specifically designed for handling streaming data.
Streaming data. So we're talking about data that's constantly being generated.
Exactly.
Like social media feeds
Yeah.
or sensor data.
Yeah? Yeah.
It's not just sitting there in the data lake waiting to be processed.
Think about a website,
Okay.
tracking user activity. Every click, every page view, that's
Yeah.
generating data in real time. That's where Kafka really shines. It can capture those events, process them, and route them as they happen.
Oh, it's kind of like a high-speed traffic controller for data,
That's a great analogy.
making sure everything gets to the right place at the right time.
Kafka acts as the central hub. It receives data from all these various sources,
Right.
organizes it into topics, and then distributes it to different systems, applications, whatever needs that data.
So while Hadoop is great for handling those large batches of data that we talked about earlier,
Right.
Kafka steps in when you need real-time insights
Exactly.
from constantly updating information.
And just like Hadoop, Kafka is designed to be distributed and fault tolerant.
Okay.
So even if one part of the system fails,
Yeah.
the data keeps flowing.
It seems like reliability and speed are like common themes.
They are, yeah. Very important when dealing with these large-scale data systems.
But how do we actually make sense of all this data
Right.
once it's in the lake?
That's where data analysis comes in. And when it comes to analyzing data in a data lake,
Yeah.
Apache Spark is a real game changer.
Spark. I've heard that name before, too.
Yeah.
It's also used for big data processing, right?
It is.
How does it differ from Hadoop?
Well, both are powerful tools, but Spark is known for its speed and versatility.
Okay.
While Hadoop excels at batch processing, handling large chunks of data at once, Spark can handle both batch and real-time processing.
Oh, okay.
So it can analyze those constant data streams we were just talking about with Kafka.
So it's like Hadoop with an extra gear
Yeah, you could say that.
for those situations where you need answers quickly.
Exactly. One of the reasons for Spark's speed is its ability to process data in memory, which is much faster than constantly reading and writing data to disk.
In-memory processing. So it's like having a super fast workspace for data analysis.
Precisely.
Okay.
This allows Spark to handle a wide range of data processing tasks, from simple transformations to complex machine learning algorithms.
Machine learning. Now we're talking about some really advanced applications.
We are, and the beauty of Spark is it integrates well with other data lake technologies like Hadoop and Kafka.
Okay.
You can use them together to build this really powerful ecosystem
Right.
that covers the entire data lifecycle from ingestion to analysis.
So it's like having a team of specialists working together,
That's a great way to put it.
each with their own strengths
Yeah.
to manage and understand the data.
And there are even more tools in this ecosystem.
Okay.
Have you heard of Elasticsearch?
Elasticsearch. The name rings a bell.
Yeah.
Isn't it something to do with like search functionality,
You're on the right track.
like on websites?
Elasticsearch is all about making your data easily searchable and analyzable in near real time.
Okay.
It's like having a superpowered index
Right.
for your data lake.
So if I need to find like a specific piece of information within my data lake, Elasticsearch can help me locate it.
Exactly. Think of it this way. You're searching for a particular customer record in a database with millions of entries. Elasticsearch can pinpoint that record in milliseconds.
Wow, that's incredible.
Yeah.
How does it achieve that kind of speed?
It uses a technique called inverted indexing,
Okay.
which essentially creates a map of all the words in your data
Okay.
and links them to the documents where they appear.
Oh, okay.
So when you search for a specific word or phrase,
Yeah.
Elasticsearch can instantly identify all the relevant documents.
So it's like having a detailed cross-reference for your entire data lake.
Exactly. And Elasticsearch isn't limited to just simple keyword searches. It can handle complex queries, filter results based on various criteria, and even analyze your data to uncover trends and patterns.
So it's not just about finding needles in a haystack.
No.
It's about understanding the haystack itself.
Exactly. And like the other technologies we've discussed, Elasticsearch is designed to be distributed and scalable. It can handle massive volumes of data and provide near real-time insights, making it a powerful tool for anyone working with data lakes.
I'm seeing a pattern here. Like all of these technologies are built to handle massive amounts of data efficiently and reliably.
You're right. Hadoop, Kafka, Spark, Elasticsearch, they've all emerged in response to the challenges and opportunities presented by the age of big data.
And we can't forget about getting the data into the data lake
Right.
in the first place.
Exactly.
What about Apache Flume?
Yes.
Doesn't it play a role in that process?
You're right. Flume is all about data ingestion.
What?
The process of collecting data from various sources and channeling it into your data lake.
So if I have data coming in from all different places,
Yeah.
databases, sensors, social media feeds,
Yep.
Flume can help me get it all into my data lake.
Exactly. Flume is designed to handle a wide variety of data sources and formats, and it can even process the data on the fly, transforming it into a format that's suitable for your data lake.
So it's like the intake valve for the data lake,
That's a great way to think about it.
ensuring a smooth and consistent flow of information.
And Flume is also highly reliable. It uses a concept called write-ahead logging, which means it stores the data to disk before forwarding it, ensuring that even if there's a system failure, no data is lost.
It sounds like these data lake systems have reliability built in at every step.
Absolutely. And Flume, like the other technologies we've discussed, is designed to be scalable and distributed.
Okay.
So you can easily adapt it to handle increasing data volumes.
So we've covered the entire data lifecycle, basically.
I have.
From ingestion with Flume
Yep.
to storage and processing with Hadoop and Kafka, analysis with Spark,
Yeah.
and search functionality with Elasticsearch.
It's a pretty impressive ecosystem.
It is.
And it highlights the power of open source software in addressing the challenges of big data.
Yeah.
These tools are constantly evolving, and we're only just beginning to explore their full potential.
This deep dive has been truly eye-opening. I'm starting to grasp the complexity and power of data lakes and the technologies that make them work.
I'm glad to hear that. And remember, this is just a glimpse into the world of data lakes. There's so much more to discover and learn.
It sounds like the world of data is incredibly dynamic.
It is.
There's always something new to learn and explore.
That's what makes it so exciting. As we generate more and more data, the importance of data lakes will only continue to grow. And with it, the need for innovative solutions.
This deep dive has been truly insightful. I feel like I've gained a whole new appreciation for the complexity and potential of data lakes.
I'm glad to hear that.
It really has. We've gone from the basics of data lakes to exploring, these powerful technologies.
Yeah.
Like Hadoop and Kafka, Spark, Elasticsearch, Flume.
Right, a lot to cover.
I feel like I've gained a whole new level of understanding.
Oh, good.
But before we wrap up this deep dive, I have one last question.
Okay.
We've talked about how these technologies work individually.
Right.
And how they kind of fit together in a data lake ecosystem.
Yeah.
But for someone who's, totally new to all of this, it still seems, pretty abstract.
I understand.
Can you give us a real-world example, like how these technologies might be used together in a practical way?
Let's imagine a large e-commerce company operating here in India.
Okay.
They have, millions of customers across the country.
Yeah.
They're generating tons of data every day, website traffic, purchase history, customer reviews, social media interactions, all of that.
Right.
And they want to use this data to improve their customer experience. Personalize recommendations, optimize their marketing campaigns.
Of course, yeah, ultimately increase sales.
Exactly.
That sounds like a perfect use case for a data lake.
It is.
But how would they actually put these technologies to work?
Well, first, they'd need to get all that data into their data lake, right?
Right.
They could use Apache Flume to collect data from their website servers, their CRM system, their social media platforms, you name it.
Okay.
Flume would ensure that data is collected reliably.
And streamed into the data lake in a structured format.
So Flume's like a data pipeline, gathering information from all these different sources and channeling it into the data lake.
Yep.
What happens next?
Once the data is in the lake, they could use Hadoop to store and process it.
Okay.
They might use Hadoop to analyze, say, historical purchase data, to identify trends and patterns in customer behavior.
Okay.
Like this could help them understand which products are most popular in different regions of India, or which demographics are most likely to purchase certain types of products.
So Hadoop helps them understand the what of their customer data.
Right.
But what about the why? Like the reasons behind those behaviors?
That's where Spark comes in.
Okay.
They could use Spark to build machine learning models that predict future customer behavior.
Oh, wow.
For example, they could create a model that predicts which customers are most likely to churn or which customers are most likely to respond to a particular marketing campaign.
Those are some incredible insights.
Right. And I imagine they could also use Kafka to handle the real-time data.
Exactly. They could use Kafka to process data from their website in real time, personalizing the shopping experience for each customer.
Okay.
For example, if a customer's been browsing products in a certain category, Kafka could trigger the website to display recommendations for similar products.
Oh, that's the kind of personalization I like.
Yeah.
It makes you feel like they're actually paying attention to my interests. And where does Elasticsearch fit into all of this?
Elasticsearch could be used to power the search functionality on their website.
Okay.
As customers type in their search queries, Elasticsearch would quickly identify the most relevant products, helping them find what they're looking for quickly and easily.
So all of these technologies kind of work together seamlessly to create this data-driven ecosystem that benefits, well, both the company and its customers.
That's the power of data lakes. They enable businesses to harness these vast amounts of data they generate to get a deeper understanding of their customers, make better decisions, and create more personalized and engaging experiences.
This deep dive has been truly enlightening. Thank you so much for guiding us
You're welcome.
through this complex and fascinating world.
It's been my pleasure. And remember, this is just a starting point. There's always more to learn and explore.
Absolutely. And for our listeners who are eager to learn more, don't forget to like, share, and subscribe to The Deep Dive for more insightful explorations into the world of data.
And be sure to check out the show notes for links to additional resources on data lakes, Hadoop, Kafka, Spark, Elasticsearch, and Flume.
Until next time, stay curious and keep diving deep. Ever tried finding like a specific invoice from like 3 years ago in a sea of company data?
Yeah.
That's the problem we're tackling today. How to retrieve information quickly from massive data lakes.
Right.
Especially for those of you used to working with relational databases.
Yeah, it's a challenge a lot of companies face, as data volumes just explode. And it's not just about finding that invoice. Like, slow search can impact everything.
Right.
From customer experience to, making those timely business decisions.
Exactly. So, in this deep dive, we're exploring a tool called Elasticsearch.
Okay.
Which is designed for speed and scale when searching these vast data repositories.
So what's interesting is that Elasticsearch approaches search very differently compared to like the SQL queries you might use in a traditional database.
Okay.
It relies on something called inverted indexing.
Okay, let's unpack that term.
Sure.
Inverted indexing sounds a bit technical.
Yeah, so think of it this way. Imagine you have a huge online store with millions of products.
When someone searches for red shoes size 8, Elasticsearch doesn't have to scan through every single product description. Instead, it has a pre-built index that instantly tells it which products match those keywords, making the search incredibly fast.
So it's like having a super organized catalog that points you directly to the relevant products.
Yeah.
Bypassing all the irrelevant ones.
Right. And this is particularly powerful in data lakes, where you have diverse data types like text numbers, dates, and even geolocations.
Wow.
Elasticsearch can index all of these, making it easy to search across your entire data landscape.
This brings up a question I've had for a while.
Sure.
How does this compare to querying a relational database?
Yeah.
We're used to SQL, so where does Elasticsearch fit in?
So that's where the key advantages of Elasticsearch really stand out.
Okay.
First, speed. Elasticsearch is built for near real-time search, often returning results in milliseconds, even for complex queries.
Traditional SQL queries can become quite slow when you're dealing with millions of rows or complex joins.
So in a fast-paced business environment, Elasticsearch gives you that speed advantage when you need insights quickly.
Exactly.
What other advantages are there?
Flexibility is a big one.
Okay.
Unlike relational databases, which require a strict schema, Elasticsearch is schemaless.
Okay.
You can index data without having to predefine its structure.
So if I'm dealing with data from various sources, maybe some social media feeds, sensor data, and customer records, I can just load it all into Elasticsearch without having to worry about fitting it into a predefined table structure.
Precisely. This is particularly valuable in data lakes, where you're constantly dealing with new data sources and evolving data formats.
This all sounds very promising,
Yeah.
especially the flexibility part. It seems like Elasticsearch could be a real game changer for companies in India
Absolutely.
that are trying to make sense of their ever-growing data lakes.
Yeah. And there's one more key advantage we need to discuss: scalability.
Okay.
As your data lake grows, Elasticsearch can grow with it. You can easily add more nodes to your Elasticsearch cluster, distributing the data and the workload, which maintains fast performance even as the data volume increases.
So it's like having a search engine that expands its capacity as needed.
Exactly.
Ensuring that those searches stay lightning fast.
Yeah.
Even if you're dealing with terabytes or petabytes of data.
That's right.
Now, in part 2 of our deep dive into Elasticsearch, we'll move beyond the technical details and explore some real-world applications.
Okay, sounds good.
We'll see how companies are using this technology to solve business challenges. Stick with us.
And don't forget to like, share, and subscribe to The Deep Dive for more fascinating deep dives into the world of data and technology.
We'll be back with part 2 shortly.
See you then. Welcome back to The Deep Dive.
Okay, so
We've been discussing Elasticsearch and its role in retrieving information quickly from large data lakes, a topic that's particularly relevant here in India, where companies are increasingly adopting this technology.
we talked about the technical advantages like inverted indexing and the schemaless nature of Elasticsearch. But now I'm curious to see how this actually plays out in real-world scenarios.
Uh-huh.
Can you give us some concrete examples?
Absolutely. Let's start with e-commerce,
Okay.
a sector where Elasticsearch is making a huge impact.
Okay.
Imagine you're running a large online marketplace with millions of products.
Yeah.
When a customer searches for something specific,
Okay.
like smartphones under 30,000 rupees with a good camera,
Right.
Elasticsearch can instantly deliver highly relevant results.
That makes sense given how fast Elasticsearch can sift through data.
Right.
But what's happening behind the scenes? How does it actually handle such complex queries?
So Elasticsearch can analyze various product attributes simultaneously,
Okay.
price, brand, features, customer reviews.
Wow.
It can even consider factors like location to show products that are available nearby. Okay. All of this happens in real time,
Right.
providing a seamless and personalized shopping experience for the customer.
So it's not just about keyword matching.
Right.
It's about understanding the intent behind the search
Yeah.
and delivering the most relevant results.
Exactly. And this ability to understand context and deliver personalized results is what sets Elasticsearch apart from traditional search methods.
This sounds like a game changer for e-commerce companies,
Yeah.
especially those dealing with massive product catalogs
Right.
and diverse customer preferences. What other industries are benefiting from Elasticsearch?
Another area where Elasticsearch shines is log analytics, which is critical for cybersecurity.
Right.
Companies generate mountains of log data from their application servers and network devices.
Yeah.
Analyzing these logs is crucial for detecting security threats and identifying anomalies.
I can imagine how challenging it must be to make sense of all that data, especially when time is of the essence in cybersecurity.
Traditional methods often involve manual analysis or writing complex scripts,
Right.
which can be slow and inefficient.
Okay.
Elasticsearch, on the other hand, can ingest these logs in real time
Okay.
and allow security analysts to perform complex searches to pinpoint suspicious activity.
So instead of sifting through mountains of data,
Yeah.
security analysts can quickly identify patterns, anomalies, and potential threats using Elasticsearch. That sounds incredibly valuable in today's world where cyber attacks are becoming increasingly sophisticated.
Absolutely. Elasticsearch provides the speed, flexibility, and scalability needed to handle the growing demands of cybersecurity. It's like having a powerful searchlight
Wow.
that can illuminate the darkest corners of your IT infrastructure.
We've seen how Elasticsearch powers fast and efficient search in e-commerce and cybersecurity.
Right.
But are there other areas where it's proving to be valuable?
Definitely. It's used in a wide range of applications, from content management systems and search engines to business intelligence dashboards and even scientific research.
Wow.
Essentially, any field where you need to quickly and efficiently analyze large data sets can benefit from Elasticsearch.
It seems like the possibilities are endless.
Yeah.
Elasticsearch is clearly more than just a simple search engine.
Right.
It's a powerful tool for extracting insights and making sense of the vast amounts of data that companies are generating today.
And this is just the tip of the iceberg in the final part of our deep dive.
Okay.
We'll explore some of the underlying reasons behind Elasticsearch's popularity and why it's become the go-to solution for so many organizations around the world.
Okay, great.
Stay tuned.
So we've seen how Elasticsearch tackles data retrieval challenges in like e-commerce, cybersecurity, and more.
Right.
Now I'm curious, what makes Elasticsearch so popular?
Yeah.
Why are companies choosing this technology over other solutions?
Well, one of the key factors is its open source nature.
Okay.
Elasticsearch is built on top of Apache Lucene, a powerful open source search library.
Oh.
This means that the core technology is freely available.
Right.
And there's a vibrant community of developers constantly contributing to its growth.
So it's not just a product developed by a single company.
Right.
It's a collaborative effort constantly being improved and refined by a global community that must contribute to its rapid evolution.
Exactly. This open source model fosters innovation. Developers can create plugins, extend Elasticsearch's capabilities, and share their knowledge.
Right.
It's like a collective effort to make Elasticsearch better and more versatile.
That explains why there's such a rich ecosystem of tools and integrations around Elasticsearch.
Yeah.
We've talked about Kibana, which helps visualize data.
Right.
Are there other notable tools in this ecosystem?
Yes. There's Logstash, which is great for collecting and processing data from various sources before sending it to Elasticsearch.
Yeah.
These tools work together seamlessly, creating a powerful platform for data ingestion, search, and analysis.
It's like having a toolbox filled with specialized tools,
Yeah,
each designed for a specific task in the data pipeline.
exactly.
But with all this power, is Elasticsearch difficult to use?
Mm.
I'm thinking about companies that might not have large data science teams.
That's another reason for Elasticsearch's success. It's user-friendliness.
Okay.
Despite its powerful capabilities, Elasticsearch is surprisingly easy to get started with. The query language is intuitive,
Okay.
and there's a wealth of documentation and a supportive community to help you along the way.
So you don't need to be a coding expert to use Elasticsearch effectively.
Right.
That opens up the possibilities for a much wider range of users.
Precisely. And that brings us to another key point, scalability.
Okay.
Elasticsearch can handle data sets of all sizes.
Right.
You can start with a single node and easily scale horizontally by adding more nodes to the cluster as your data grows.
This means Elasticsearch can adapt to the needs of both small startups and large enterprises. It's a future-proof solution that can grow alongside your data volume and business requirements.
That's a great way to put it.
Yeah.
Elasticsearch's scalability is one of its major strengths, especially for companies in India that are experiencing rapid data growth.
This deep dive into Elasticsearch has been incredibly insightful.
It has.
We've seen how it tackles the challenge of fast data retrieval in large-scale data lakes,
Right.
and we've explored its impact on various fields, especially here in India.
Absolutely.
I think it's safe to say that Elasticsearch is a game changer.
I agree.
For anyone working with large data sets,
Yeah.
it's a powerful tool that can help us unlock insights and make better decisions.
Couldn't have said it better myself.
And on that note, we wrap up our deep dive into Elasticsearch.
Thanks for joining us.
We encourage you to explore further and discover its vast capabilities.
And don't forget to like, share, and subscribe to The Deep Dive for more fascinating explorations into the world of data and technology.
Until next time. All right, so let's dive into something pretty crucial for anyone working with data, especially if you're already familiar with relational databases.
Okay.
How do we actually get that processed data from our data lake out to applications and users?
That's a great question because, a data lake is like this massive reservoir of raw data.
Right?
Having it is one thing, but making it actually useful,
Yeah.
that's where things get interesting.
Right, so it's not as simple as just connecting to the data lake and pulling out whatever we need.
Not quite.
Okay.
Imagine trying to drink directly from a reservoir.
Uh-huh.
You'd want some filtration, some
Yeah.
purification before consuming that water, right?
For sure.
Similarly, we need a way to refine and deliver that data in a format that applications and users can readily understand and work with.
Okay.
That's where the serving layer comes in.
So the serving layer. This sounds like this is the key to making our data lake truly valuable.
Absolutely.
What exactly does it do?
It acts as the bridge between the processed data in your data lake and the applications or users who need it.
Right.
It takes care of things like exporting data in specific formats, publishing messages to other systems, and offering various ways to access the data.
Got it.
So it's like the distribution center of our data reservoir.
Okay, that makes sense. So if an application wants to access customer data,
Yes,
the serving layer would handle that request.
exactly. It's responsible for ensuring the application gets the right data in the right format securely and efficiently.
Okay.
And there are different technologies we can use to build out this serving layer.
Got it. Let's get into those technologies.
Sure.
I've heard a lot about REST APIs. How do they fit into the picture?
REST APIs are incredibly popular for exposing data because they're simple to understand and can be used by a variety of programming languages and systems.
Oh.
Think of it as a universal language for applications to talk to each other.
Okay.
Okay.
Yeah.
All right. So the serving layer would use a REST API to send the requested customer data back to the application.
Okay, so it's sending it back to the application.
Precisely, a key benefit of REST APIs is that they're built on standard HTTP methods,
Uh-huh.
like GAT for retrieving data post for adding data and PET for updating data.
Right.
It makes them very versatile. Plus, they offer features like caching, which stores frequently accessed data for quicker retrieval, and security features to control who can access what.
Okay, so caching sounds like a great way to speed things up.
It is.
Are there tools to help visualize and manage these REST APIs?
Absolutely. Swagger UI, for instance, is a tool that allows developers to see a clear representation of the API understand what data is available, and even test out API calls.
Okay.
It's like a user manual for the API.
That makes a lot of sense. That makes it much easier for developers to work with the data.
Absolutely.
But I've also come across this term GraphQL.
Yes.
How is that different from REST APIs?
That's a great question. GraphQL offers an even more focused way to access data.
Okay.
Imagine you have a large data set, but an application only needs a few specific pieces of information, like a customer's name and email address.
With REST APIs, we'd have to fetch the entire customer record, even if we only need those 2 fields.
That's right. With GraphQL, you can request exactly the data you need, nothing more and nothing less.
Okay.
It sits on top of REST APIs, providing a layer of fine-grained control over the data that's being retrieved.
So it's all about efficiency and avoiding unnecessary data transfer.
Absolutely.
What are the advantages of using GraphQL in serving layer?
Well, for applications that require very specific data points, GraphQL can significantly reduce the amount of data that needs to be transferred, leading to faster responses and a better user experience.
Right.
It's especially beneficial when dealing with complex nested data structures.
This is making a lot of sense that we've got these modern ways of accessing data.
Yeah.
But what about traditional relational databases?
Yeah.
Do they still play a role in the serving layer of a data lake?
Absolutely. Relational databases are still incredibly valuable, particularly for managing structured data. They offer strong consistency and transactional guarantees, which are essential for many applications.
Right. But how do we connect them to the data lake, which often deals with various data formats?
We can use JDBC drivers, which provide a standard way for applications to interact with relational databases.
Okay.
Additionally, we can design carefully crafted views within the database to expose only the specific data that needs to be accessible through the serving layer.
Okay.
It's like creating a curated window into the database.
Got it.
Yeah. And it's important to remember that not all data in a data lake is neatly structured like in a relational database.
Right.
We often have semi-structured and unstructured data too.
Right. It's not all tables and rows. Can you give me some examples of these different data types within the data lake?
Absolutely. Semi-structured data might be something like JSON or XML documents, email data, or even chat logs.
Okay.
It has some inherent organization, but isn't as rigid as a database table.
Okay, that makes sense. And unstructured data, I imagine that's even more diverse.
It is, think of images, videos, audio files, or large text documents. It doesn't fit neatly into predefined categories.
Okay.
And interestingly, this kind of data can be incredibly valuable because it often captures the nuances of human behavior.
So how do we even begin to process and analyze unstructured data? It seems like a massive challenge.
It is a challenge, but we have tools for that.
Okay.
Technologies like natural language processing, image recognition, and machine learning are used to extract meaningful insights from this unstructured data.
Okay.
It's a rapidly evolving field with amazing potential.
So connecting this back to the serving layer, it needs to be flexible enough to handle all these different types of data, not just structured data from relational databases.
Exactly. It's not just about connecting to a database and pulling out records. The serving layer might need to interface with specialized search engines, content indexing systems, or even deal with real-time data streams.
Real-time data streams now. That sounds intriguing.
Yeah.
What exactly are those?
Imagine being able to analyze and act on data as it flows into the data lake, not just after it's been batched and processed.
Okay.
That's the power of real-time data streams.
Give me an example of how that would be useful.
Let's say you're tracking website activity.
Okay.
With a real-time data stream, you could analyze user behavior in the moment and potentially personalize their experience, recommend products, or even offer targeted content as they browse.
That's incredibly powerful. So how do these real-time data streams actually work? What kind of technology is involved?
One popular technology for handling real-time data streams is Apache Kafka.
Okay, I've heard of Kafka. It's a messaging system, right?
It's more than just messaging. Kafka is a distributed streaming platform. Think of it as a high-throughput pipeline for data.
Okay.
It can handle massive volumes of data flowing in from various sources and make it available for real-time processing.
So in the context of our data lake, Kafka could be part of the serving layer, delivering these real-time insights to applications.
Precisely, Kafka can connect to the speed layer of the data lake, which handles the real-time data ingestion. And processing this allows the serving layer to provide both a real-time view of the data through Kafka, alongside the historical insights from the batch layer, where data is processed in larger chunks.
This raises an interesting question. If we have these powerful real-time data streams with Kafka, do we even need the batch layer anymore? It seems a bit old-fashioned in comparison.
That's a great point. It's where the idea of the Lambda architecture comes in. This architecture suggests that both batch and speed layers are still important. The batch layer provides comprehensive historical analysis, while the speed layer gives us real-time insights. And what does the serving layer do? It acts as the orchestrator, blending those two perspectives into a unified, comprehensive view of the data.
So the serving layer isn't just a delivery mechanism, it's also this point of integration for different processing approaches.
It brings together the diverse facets of the data lake, real-time insights from Kafka historical trends, from the batch layer, even specific data points from a connected relational database. The serving layer pulls it all together.
This has been really eye-opening. What stands out to me is how the serving layer is like the central nervous system of the data lake. It connects all the parts and makes it a truly intelligent system.
That's a great analogy, and that's why the serving layer is such a critical part of modern data architecture. It's the bridge between the vast potential of the data lake and the applications and users that can turn that data into valuable actions and insights.
But building this serving layer, especially with all these different technologies and types of data, sounds incredibly complex. Where do we even start?
It can seem daunting, but there are some key principles to guide you. Firstly, you have to think about scalability as your data lake grows. The serving layer needs to handle increasing volumes of data and requests without breaking a sweat.
So we don't want it to become a bottleneck as our data needs expand. What else should we consider?
Performance is critical. The serving layer should be able to deliver data quickly and efficiently, especially if we're talking about real-time applications that need to respond in milliseconds.
That makes sense. Things like caching and optimized query processing must be essential here.
Absolutely, and we can't forget about security. The serving layer is the gateway to your valuable data, so protecting it from unauthorized access is paramount.
That's a crucial point. We've invested so much in building this data lake. We don't want that data falling into the wrong hands.
Exactly. A robust security framework, including authentication, authorization, and encryption, needs to be baked into the design of the serving layer.
So we've got scalability, performance, and security as the pillars of a well-designed serving layer. But how do we choose the right technologies to build it? It seems like there's so many options.
There is no one-size-fits-all solution. The best approach is to select the tools that align with your specific requirements. For instance, if you're dealing primarily with structured data and need strong transactional consistency, a good old relational database might still be the best choice.
But if the focus is on serving up data for analytics and visualization, something like Elasticsearch, which is designed for fast search and analysis, might be a better fit.
Precisely. And of course, if you need those real-time data streaming capabilities we discussed, Apache Kafka would be a natural part of the architecture.
Here's where it gets really interesting for me. The serving layer isn't just a SCADA component. It's this adaptable and intelligent layer that can evolve alongside the data lake.
That's the beauty of it. It's a dynamic ecosystem that can adapt to changing needs and embrace new technologies as they emerge.
Okay, so for someone who's starting to explore the world of data lakes and wants to make their data truly useful, what are the key takeaways about the serving layer?
I'd say the most important takeaway is that the serving layer is not an afterthought. It's a foundational piece of your data lake architecture and needs to be considered from the very beginning.
And it's not just about dumping data out. It's about making that data accessible, usable, secure, and performant for the applications and users who need it.
You got it. The serving layer is truly the key to unlocking the value of your data lake.
This has been an amazing deep dive.
Yeah.
We've gone from the basics of what the serving layer is to some really advanced concepts like real-time data streams and adaptable architectures. It's a fascinating and rapidly evolving space.
And it's only going to become more critical as data lakes continue to grow in size and complexity.
Well, on that note, I think it's time to wrap up this deep dive. But before we go, I want to leave our listeners with one final thought. We've talked a lot about technology today, but the real power of a data lake lies in the insights it can provide.
Absolutely. The serving layer is simply a means to an end. The real goal is to use the data to make better decisions, improve processes, and uncover new opportunities.
So as you continue your journey into the world of data lakes, remember to focus on the insights, not just the technology. And with that, we'll see you in the next deep dive. Don't forget to like, share, and subscribe. All right, data lakes. You know, relational databases, right?
Right.
It's like that, but bigger, way bigger.
Yeah, think of it like a massive pool of all sorts of data, not just the neat rows and columns, but everything. Social media, sensor readings, website clicks.
A bit overwhelming.
Yeah.
How do we even make sure all that data is, good quality, secure, and compliant with all the rules.
Definitely a challenge. That's where data governance comes in. It's like a set of guidelines, not just rigid rules, more like a collaborative way to manage data responsibly.
So we all got to work together, huh?
Right.
But how do we actually check the data quality when it's so all over the place?
Well, we use data auditing. Think of it like a regular checkup for your data, looking for errors or inconsistencies, anything that might be a problem.
Like making sure all the email addresses are actually reading right and the dates are in the right format.
Exactly. Or even spotting strange things like a sudden spike in website traffic could be a security breach.
Oh, that's a good point. Regular checkups are key. But what if we do find something wrong? During those audits, how do we trace it back to the source and fix it?
That's where data lineage is super helpful. Imagine you can actually trace the path of your data from where it started through every change it went through, like a map.
So like if we have a customer record that's messed up, we can use this lineage thing to pinpoint where the error happened and fix it at the root of the problem.
Precisely. It helps us understand the whole life cycle of the data, makes it way easier to troubleshoot problems.
Makes sense. But I don't know, it all seems so detailed. Doesn't it get confusing keeping track of it all?
Well, that's where metadata management comes in. Think of metadata as the information about your data. It tells you what it means, where it came from, how it's structured.
Like if I'm looking at a photo on my phone, the metadata tells me when I took it, where I was, right? What kind of camera I used.
Yeah, exactly. It gives you that same level of understanding, but for all the data in your data lake.
So it's like the instruction manual for the data, so we don't misinterpret anything and everyone's on the same page.
Exactly. And there's actually a tool that can help us manage all this metadata, Apache Atlas.
Oh, tell me more about this Atlas.
So Atlas is an open source framework built specifically for data lakes. It's like a central hub for all your metadata.
So it keeps everything organized and easy to find.
Yeah, it helps us make sense of all that data. We'll dive deeper into Apache Atlas and its features after a short break.
Welcome back. So we talk about data governance and getting that data into the lake, right?
Right. But how do we actually get it in there? What's that process like?
So think of the data lake like a reservoir, right? We need channels to bring in water, or in our case, data from all these different places.
Some sources, yeah.
Exactly. And some of those sources, they're like a steady stream. But others, they come in like bursts.
I see. So how do we manage that? All those different flows? Well, let's start with batch data. Think of big chunks of data, stuff we move, say, at specific times, like on a schedule.
Okay, so scheduled data transfers, what do we use for that?
We use tools like Apache Scoop. You can think of it kind of like a fleet of trucks moving data from our existing systems to the lake efficiently.
Gotcha. So say if I have a bunch of customer records in my SQL database and I want to get them into the lake, Scoop can handle that.
Absolutely. It's like a bridge between those traditional databases and the data lake environment.
Makes sense. But what about data that's more real-time, like those website clicks we talked about?
Yeah.
Or like sensor readings, stuff that's constantly coming in?
For that, we have things like Apache Flume. Think of it as a network of pipelines, channeling data into the lake continuously, website stuff, sensor data, social media feeds. Flume keeps it all flowing.
Okay, so Flume handles the constant stream, and Scoop does those bigger scheduled transfers. But still, that's a ton of data. How do we even manage it all once it's in the lake?
That's a great question. And that brings us to Apache Kafka. Think of it as like the nervous system of the data lake.
Kafka, yeah, I've heard that name. It's a messaging system, right?
It's more than just messaging. It's like a conductor, making sure all the data gets where it needs to go at the right time. So different parts of our data ecosystem can talk to each other, share information smoothly.
So it's like coordinating all the data movement within the lake.
Exactly. And it does it really fast, super efficient.
I gotta say, this is getting pretty complex. Is there anything that can help us visualize all this, these data pipelines, so we don't get lost in all the technical stuff?
There are tools like Apache NiFi. It gives you this visual interface for designing your data flows. You can, drag and drop things, build these complex pipelines without having to write code.
So it's like a dashboard for our data lake.
Yeah, you could say that. The idea is to make all these powerful technologies easier to use, more accessible.
That's good. So we've got the data in the lake, and we're managing how it moves around. What's next? What do we do with all that data?
That's where the real fun begins. We analyze it, we extract insights, and use them to make smarter decisions. That's what we'll explore in the final part of our deep dive.
Okay, so we've got our data lake all set up. The data's flowing in. We're managing it. Now what? What do we actually do with all this data?
Now we get to the exciting part, analyzing it, figuring out what it all means, and using that knowledge to make better decisions.
Right. But how do we even start analyzing something this massive?
Well, it depends on what we're trying to do, right? There's no single solution. It's more like having different tools for different jobs.
Okay, yeah, I get that.
So for example, if we're talking about like large-scale processing, transforming huge amounts of data, then we can use something like the Hadoop MapReduce framework.
Hadoop MapReduce.
Yeah.
Powerful stuff, huh?
Oh, yeah. It's like using a giant machine to sift through mountains of data and find those nuggets of valuable information.
Okay, so like generating reports, finding trends over time, even training those machine learning models everyone's talking about.
Exactly. But sometimes we need to do things a little more focused.
More focused.
Yeah, like let's say we want to search for specific customer records or see how different data sets are connected. MapReduce might be overkill for that.
Right. Too much firepower. So what do we use then?
We have tools like Apache Hive and Impala. They give us this interface that's a lot like SQL.
SQL. Ah, now you're speaking my language.
So it makes it easier for analysts to explore the data, to ask specific questions, and get answers fast.
So it's like Hive and Impala for those precise tasks, while MapReduce is for the heavy lifting.
That's a good way to put it. And then you have tools like Apache Drill and Presto. Those are built for speed.
Speed.
Yeah, they can handle these massive data sets and give you answers almost instantly.
Sounds impressive. So many tools to choose from.
There are. And the field it's constantly evolving. Always new tools popping up, new ways to analyze data.
That's kind of cool, actually. Always something new to learn. But it's not just about crunching numbers, right? We have to make sense of it all.
Oh, absolutely. That's where data visualization is so important. It's like turning raw data into a story, something that people can actually understand and use to make decisions.
So instead of just looking at a bunch of spreadsheets, we can create charts and dashboards, make it more visual.
Exactly. There are tools like Tableau, Power BI. They let you create these interactive dashboards, maps, all sorts of things.
That makes sense. And then with cloud platforms like AWS and Azure, you can access that data from anywhere, right?
Yep. The cloud has changed everything. We have all these resources, all these tools right at our fingertips.
Amazing. Well, I think we've covered a lot of ground here. We talked about keeping our data organized, getting it into the lake, and then all the amazing things we can do with it.
We have. And it's really fascinating how all these pieces work together, right?
It is.
It allows companies to really, truly understand their data and use it to do incredible things.
Couldn't have said it better myself. This has been a really, really insightful deep dive.
Yeah.
Learned a lot. But before we wrap up, I want to leave our listeners with a thought. It's great to have all these amazing tools and techniques, but at the end of the day, it's all about the questions we ask.
Right.
It's about challenging our assumptions and using data to make the world a better place.
Very well said. Data is powerful. We need to use it wisely, responsibly.
Absolutely. Well, thank you for joining us for this deep dive into data lakes. We hope you found it valuable. If you did, please consider liking, sharing, and subscribing to the deep dive for more explorations into all sorts of fascinating topics. Until next time. Okay, so we're diving into data lakes today.
Yeah.
You're probably familiar with relational databases, right?
Yay.
But imagine something way bigger.
Much more diverse.
Yeah, exactly. That's a data lake. We're talking about bringing in data from, well, everywhere. Your CRM system,
social media,
website logs,
even sensor data.
all in one place.
Exactly.
Yeah.
It's all about breaking down those data silos and finding insights you wouldn't get before.
And that's what this deep dive is all about, right? Understanding how a data lake actually works. Not just the idea, but how the pieces fit together to make it all happen.
And a big part of that is the Lambda Architecture, which helps you make sense of all that data. Whether you need insights right now or you want to analyze long-term trends, it can handle it.
Okay, Lambda Architecture.
Yeah.
I'm intrigued. Break it down for me. What makes this approach so special?
Well, think of it as having two powerful engines working together. One is the batch layer, often using Hadoop. Perfect for processing massive amounts of historical data. It can uncover those deep hidden patterns that you might miss in the everyday rush of information.
Okay, so that's for the big picture stuff. What about when you need insights, like right now?
That's where the speed layer comes in. It handles data as it comes in using technologies like Apache Flink. It gives you near real-time reactions. This allows for things like instant alerts or quickly adapting to changing conditions.
So it's like having a constant pulse on the data, watching for anything that needs immediate attention. But how do these two layers, the batch and the speed, how do they work together?
That's where the serving layer steps in. Think of it as a bridge. It brings together the insights from both the batch and speed layers, gives you that complete picture, whether you're looking at long-term trends or what's happening right this second.
Okay, that makes sense. So we have this powerful architecture. But what about the data lake itself? What are the pieces that make it all work, the key components?
Well, let's start with the messaging layer, often handled by Apache Kafka. Think of Kafka as a super efficient data pipeline, making sure that constant flow of data gets to the right places without any leaks or delays.
Right, so Kafka keeps the data flowing smoothly, but what happens when the data gets to where it's going? How does it actually get, processed, turned into something useful?
That's the data processing layer, usually powered by Apache Flink. Flink is like the master chef of your data lake. Takes all that raw data, cleans it up, transforms it, turns it into, insightful dishes ready to be served.
So Kafka brings the ingredients, Flink whips it all up into something we can actually use. I like that analogy.
Exactly. But you need somewhere to store all this data, both raw and processed. That's where Apache Hadoop comes in. It forms the data storage layer, the bedrock of your data lake. Hadoop is designed to handle those huge amounts of data, giving you that stable and scalable foundation for your entire lake.
Hadoop, the foundation of it all. But with a lake this big, how do we find what we need quickly? It's not like we could just jump in and search, right?
Absolutely. That's where the index data store comes in. This is usually Elasticsearch. Elasticsearch is like a super-powered search engine for your data lake. Allows for crazy fast queries, even with huge data sets and complex data analysis. Makes it easy to find the insights you're looking for.
So Elasticsearch is the one helping us navigate this massive lake and find the treasure buried within.
Precisely. It's about making that data accessible, making it useful.
All right, this is starting to come together. We've got Kafka delivering the data, Flink processing it, Hadoop storing it, and Elasticsearch helping us find what we need. But managing a system this complex, it can't be easy. What are some of the challenges that come with data lakes?
You're right, there are challenges. One of the big ones is data partitioning. Essentially, organizing all the data in your lake in a way that makes sense. It's like you wouldn't store all your files in one giant folder on your computer, would you?
No way, that would be chaos.
Exactly. You need to divide the data based on different things, like the type of data or where it came from. Makes it easier to manage, analyze, and find what you need later on.
So it's like creating different compartments within the lake.
Exactly. And just like a real lake, you have to keep the water clean, right?
Yeah, you don't want a polluted lake.
Right. In a data lake, that means data validation and cleansing. Bad data leads to bad decisions, so you need to make sure your data is accurate, consistent, and in the right format.
Right, garbage in, garbage out, like they say. So the data is organized, it's cleaned, but what about protecting all this information? Security has to be a huge concern with a system like this.
Absolutely. Data lake security is paramount. You need access control, making sure only the right people can see the data, and encryption, scrambling the data so it's unreadable without the key.
Okay, so access control and encryption are the basics. But we talked about Apache Knox and Ranger earlier. Where do they fit in?
Apache Knox is like a gateway. It gives you a single point of access to the data lake and manages authentication and authorization.
So it's like the security guard at the entrance.
Exactly, and Ranger goes a step further. It gives you fine-grained control over who can access what data within the lake based on their roles and permissions.
So even within the lake, different people might have access to different areas.
Precisely. By combining access control, encryption, and tools like Knox and Ranger, you can create a really strong security system for your data lake. Protect it from unauthorized access and potential breaches.
This has been a fantastic start to our deep dive. I'm already eager to learn more.
There's definitely more to come. In the next part, we'll really dig deep into the Lambda architecture and see how it pulls all these different pieces together to really unlock the potential of your data lake.
I'm ready when you are. Let's dive back in.
Welcome back. So last time we talked about how different components like Kafka, Flink, and Hadoop all come together to form a data lake.
Right, we laid the groundwork.
Yeah. Now let's see how the Lambda architecture actually ties it all together.
That's what I'm really curious about. We touched on the batch and speed layers, but I want to understand how they actually work with those components.
Okay, sure. Let's start with the batch layer. It's all about that deep analysis of historical data. Remember Hadoop?
Yeah.
That's the workhorse here. The batch layer takes raw data from the data lake storage and sends it over to Hadoop for processing.
So it's using Hadoop's power to, what, sift through those massive data sets and uncover those long-term trends we were talking about.
Exactly. Think of it like sifting through layers of sediment at the bottom of a lake. It takes time and effort, but you can find some really valuable insights buried down there.
Okay, that's the batch layer, slow and steady, revealing the past. What about the speed layer? How does that fit in with the components?
Well, the speed layer is all about agility, reacting in near real time. That's where Apache Kafka comes in. Remember that super efficient data pipeline?
Right.
Kafka delivers those continuous streams of incoming data to the speed layer, where Apache Flink then takes over.
So Flink's the one processing the data as it comes in, allowing for those quick decisions and reactions.
Precisely. Imagine sensors constantly checking the link's conditions.
Temperature, currents.
Yeah, all of that. And any sudden disturbances, that's the speed layer, constantly analyzing and reacting to the most up-to-date information.
So we've got these two layers, the batch and the speed, running in parallel, one focused on the past, the other on the present. But where do those insights actually go? How do they become useful?
That's where the serving layer comes in. It's the bridge between the batch and speed layers, combining those long-term trends with real-time insights to give you a unified view of your data.
A complete picture, no matter if we're looking at historical data or what's happening right now.
Exactly. And this complete picture is then delivered to the users and applications that need it, empowering them to make smarter decisions.
The Lambda architecture is pretty elegant, isn't it? It combines these two very different approaches, batch processing and real-time processing, into a single, unified system.
It really is a clever solution, and it's what makes a data lake so powerful. You get the best of both worlds, the depth of historical analysis and the agility of real-time insights.
But with all this data coming in and being processed, managing a data lake has got to be a pretty complex task. What are some of the key things to keep in mind to make sure this whole system runs smoothly?
Well, one of the most important things is data partitioning, which we mentioned before. You have to organize the data within your lake in a way that makes it manageable, that makes it efficient to work with.
So instead of just dumping all the data into one giant pool, we're dividing it up based on specific criteria.
Precisely. Imagine you've got a library with millions of books. Would you just pile them all up randomly?
Of course not.
Right. You'd organize them by genre, author, topic, that kind of thing.
Right. Makes it a lot easier to find what you're looking for. So we're applying that same logic to the data in our lake.
Exactly. Data partitioning makes it easier to manage different data sets. It can improve query performance, and it helps you optimize your storage resources.
Okay, so we've got our data organized. But how do we know that the data itself is accurate, reliable? We talked about data validation and cleansing before.
Yeah, absolutely. Those are critical steps. Data validation makes sure that the data follows the rules, meets the standards, like checking for valid email addresses, making sure dates are in the correct format, that kind of thing.
So it's like a quality check.
Exactly. And data cleansing takes it a step further. It fixes any inconsistencies or errors in the data. This could be things like removing duplicate entries, correcting typos, filling in any missing values.
So it's all about making the data as clean and accurate as possible.
Precisely. Think of it like this. If you've got a lake full of polluted water, you wouldn't want to drink from it, right? Or swim in it.
Definitely not.
Same with data. If it's full of errors, if it's inconsistent, you can't really trust the insights you get from it.
Great analogy. So data partitioning, validation, and cleansing, all super important for a healthy and well-functioning data lake.
Couldn't agree more. And there's another crucial aspect we need to talk about. Security.
Right. With all this valuable data in one place, security has to be a top priority.
It absolutely is. Data lake security, it's a big challenge. And it starts with access control, making sure that only the right people, authorized users, can access the data. And even then, their access is limited to just what they need to do their jobs.
So controlling who can see what data within the lake.
Exactly. And along with access control, encryption is key. It basically scrambles the data so that it's unreadable to anyone without the right decryption key.
So even if someone gets in without permission, they can't make sense of the data.
Exactly. Encryption protects data both when it's stored and when it's being moved or processed.
Okay, so access control and encryption, those are the foundation of our security. But we mentioned Apache Knox and Ranger earlier. What do they do?
Sure. Apache Knox is like a gateway. It provides a single point of access to the data lake and manages, authentication and authorization.
It was like that security checkpoint at the entrance to the lake?
Exactly. Make sure you have the right credentials to get in. And Ranger takes it even further. It provides really specific controls over who can access what data within the lake itself, defines policies that dictate who can access specific data resources, all based on their roles and permissions.
So even inside the lake, people have different levels of access depending on what they need.
Precisely. Combining access control, encryption, and tools like Knox and Ranger allows you to create a really robust security framework for your data lake. Keeps your data safe from unauthorized access and potential breaches.
This deep dive into data lake security has been really insightful. It's clear that security is a crucial part of the entire data lake architecture.
I agree. It's not just an afterthought. It has to be built in from the beginning. And it's an ongoing process. You always have to be vigilant and adapting to stay ahead of those evolving threats.
Well, we've covered a lot in this part. We've explored how the Lambda architecture integrates with the different components of a data lake and how we can handle the challenges of data management and security.
Yeah, we've laid a good foundation for understanding how a data lake works. But the really exciting stuff is seeing how this technology is being used in the real world.
That's what I'm ready to see next. Let's jump into part 3 and explore how organizations are using data lakes to innovate and tackle real-world problems.
Sounds good to me. Let's dive into the world of data lake applications.
Welcome back. We've really gone deep into the architecture and how data lakes work, but now I'm excited to see how it's actually being used out there in the real world.
Right. Seeing these concepts in action, that's the fun part. So let's look at some examples, some use cases across different industries.
Yeah, let's do it. Where are data lakes making the biggest difference? What are some of those areas?
One area that's really exciting is cybersecurity. With all the threats out there constantly changing, security teams are just drowning in data.
Yeah, I bet.
Network logs, security alerts, threat intelligence feeds, all from different sources. It's a lot.
It's got to be a nightmare trying to make sense of it all.
It is. And that's where a data lake can really change the game. By bringing all that data together in one place, security teams can finally get a complete view of their security.
So like a central command center where they can see everything that's happening.
Exactly. They can use that Lambda architecture to analyze historical data, real-time data, identify patterns, anomalies, potential threats that they might have missed before.
So they can actually, predict and prevent attacks, not just react to them after the fact.
Exactly. It's all about moving from reactive to proactive security.
Wow, that's really powerful. What other industries are seeing these kinds of benefits from data lakes?
Retail is another great example. Retailers have so much data about their customers, their buying habits, their preferences,
Oh, yeah. They've been trying to use that data for years to personalize marketing and all that.
Right. And data lakes are giving them the tools to do that even better. By analyzing customer data, retailers can create personalized recommendations, target promotions more effectively, and even optimize pricing strategies in real time.
So it's about understanding each customer individually and giving them a tailored experience.
Yeah, exactly. Moving from mass marketing to personalized marketing. And data lakes are helping retailers achieve that.
So we've got cybersecurity, retail, any other standout examples?
There are tons of applications emerging across industries. Healthcare, data lakes are helping improve patient care because they provide a more complete view of all the patient data.
That makes sense. The more information doctors have, the better decisions they can make about patient care.
Exactly. Finance. They're using data lakes to detect fraud, manage risk, and personalize financial products.
So again, it's about understanding individual needs and customizing the experience.
Right. And it goes on. Manufacturing, data lakes are being used to optimize production, transportation, improving logistics, energy, managing resources more efficiently.
Seems like every industry can benefit from data analytics in some way.
That's the point. Data is becoming so valuable, and data lakes provide the framework to make the most of that value. It's not just about collecting data, it's about understanding it, analyzing it, and using it to make better decisions.
This has been a fascinating journey for sure. We started with the basics of data lakes, and now we're seeing how they're actually changing the world. What's the one thing you want our listeners to take away from all of this?
Data is everywhere, and it has the potential to revolutionize every industry. Data lakes give us the tools to unlock that potential. It doesn't matter if you're in cybersecurity or retail, healthcare, any field, really. The ability to use data effectively, that's going to be critical for success going forward.
So if our listeners are interested, what should they do next? Where should they go from here?
Keep learning. There are tons of resources online. And there are communities full of data professionals who are more than happy to share their knowledge and experience. Dive in, play around, and see how data lakes can help you make a difference.
That's a great call to action. And if you enjoyed this deep dive into data lakes, hit that like button, share it with your friends, and subscribe to our channel for more insightful explorations of the data world and the world of technology. We're here to help you navigate this ever-changing data landscape. Until next time, keep exploring.
All right. So today we're diving into data lakes, and you're all familiar with relational databases, of course, but we're going to be going a little bit beyond those neat rows and columns today to explore how companies are using data lakes to solve real-world problems, especially here in India. From stopping cyber attacks before they even happen to giving you those eerily perfect product recommendations online, we're going to uncover the hidden power of data lakes and see how they're changing the game in cybersecurity, customer analytics, warehouse management, .OT, and even regulatory compliance. So buckle up. This is where databases get really interesting. And hey, if you're enjoying this deep dive, don't forget to like, share, and subscribe for more insightful episodes. Now, I'm curious, how are companies using data lakes for more than just, those standard reports?
Well, that's a great question. It's where the real excitement begins. Data lakes are evolving from simple reporting tools into these central hubs for all sorts of data. Think of it like this. Your company has all this data scattered across different departments and systems, right? Sales data, marketing data, customer service logs, even sensor data from warehouses. A data lake brings all of this together, allowing different teams to not just see the bigger picture, but also act on it in a coordinated way. And the magic is it's not just about structured data like what you'd find in a traditional database. We're talking about bringing in semi-structured data like JSON and XML. And even unstructured data like social media posts, images, videos, and text documents. This is huge GE for Indian businesses. Because think about the sheer volume of social media data we generate here. Data lakes can tap into this gold mine to understand customer sentiment, track trends, and personalize those marketing campaigns in a way that truly resonates.
Okay. I'm starting to see how data lakes are like this giant melting pot of data, blending everything together. But can you give me a specific example of how this melting pot actually helps businesses go beyond basic reporting? Like, what's a problem that a data lake can solve that a regular database just can't?
Sure, let's take cybersecurity. Imagine a scenario where a hacker is trying to break into a company's network. Now, a traditional security system might only look at individual events, like failed login attempts. But a data lake can pull in data from allied security systems, network logs, user activity, even external threat intelligence feeds. By analyzing all this data together, the data lake can spot patterns and anomalies that would otherwise go unnoticed. It's like connecting the dots. A few failed logins might not seem like much on their own, but when combined with unusual network activity from a specific location, bam, the data lake can flag this as a potential attack in real time.
So instead of just reacting to attacks after they happen, companies can now proactively identify threats before they even become a problem. That's incredible. But what about understanding customers? I mean, we all know how companies are collecting data on what we buy, what we click on, even what we post on social media. How does a data lake change the game in customer analytics?
Here in India, with our diverse customer base and rapidly evolving market, understanding your customers is more important than ever, and a data lake can be the key to unlocking that understanding. Let's say you're an e-commerce company like Flipkart or Myntra. You have data on what customers are browsing, what they're adding to their cart, what they're buying, even their reviews and social media interactions. But this data is often siloed in different systems. A data lake brings it all together to create a 360-degree view of each customer. Now imagine being able to use this single customer view to personalize product recommendations, tailor marketing campaigns, and even predict what a customer might need before they even know it themselves.
Okay, that makes sense. But I have to admit, all this talk about online shopping and cybersecurity makes it sound like data lakes are only for the digital world. What about physical spaces like a warehouse? How does a data lake fit into that picture?
You might be surprised to learn that data lakes are actually transforming warehouse management in a big way. Think about all the data generated in a warehouse: inventory levels, stock movements, delivery schedules, even sensor data on temperature and humidity. Now imagine a warehouse that automatically knows when to reorder supplies based on real-time data, can optimize its layout based on changing demand patterns, and can even predict potential delays before they disrupt operations. That's the power of a data lake.
Wow, so it's like having a super smart warehouse that can almost think for itself. That's amazing. But with the Internet of Things exploding all around us, with smart cities, connected cars, wearable tech, how on earth can data lakes keep up with this massive influx of data from all these devices?
That's a great question, and it's where things get really interesting. You see, data lakes are built on a foundation of some pretty powerful technologies that allow them to not only store this massive amount of data, but also process and analyze it in real time. It's like having a giant library for all your data, but instead of dusty old books, you have these lightning-fast librarians who can instantly find exactly what you need. That's a fantastic analogy. One of the key players here is Apache Hadoop, which is like the backbone of many data lakes. Hadoop provides a distributed storage system called HDFS. Think of it like rows and rows of bookshelves that can hold vast amounts of data. And it also has a processing framework called MapReduce, which is like a team of super efficient librarians who can quickly sift through all those bookshelves and find the information you need. And the best part is Hadoop is designed to scale horizontally, meaning you can just keep adding more bookshelves and librarians as your data grows.
Okay, so Hadoop is the heavy lifter storing and processing all this data. But how does the data actually get into the data lake in the first place? I mean, we're talking about data coming from all sorts of sources, right?
Absolutely, and that's where data ingestion tools come in. For batch data, which is data that's collected and processed in bulk at scheduled intervals, we often use Apache Scoop. It's like a super efficient delivery truck that can quickly transport large volumes of data from traditional databases into the data lake. But for real-time data, like the constant stream of information coming from IoT devices or social media feeds, we need something more like a high-speed conveyor belt. That's where Apache Flume comes in. Flume is designed to collect, aggregate, and move large amounts of streaming data into the data lake without missing a beat.
Okay, so we've got the data flowing into the data lake thanks to Scoop and Flume, but now we need to actually DO something with it, right? How do we make sense of all this raw data and turn it into actionable insights?
That's where the real magic happens, and we have a whole arsenal of tools for processing and analyzing the data. For batch processing, which is like analyzing a large stack of reports all at once, Apache Spark is the go-to tool. Spark is known for its speed and efficiency in handling large-scale data processing tasks. It's like having a team of super-fast analysts who can crunch through mountains of data in minutes.
Spark sounds incredibly powerful. But what about processing those real-time data streams? Like, what if we need to analyze sensor data from a connected car or a smart city as it's being generated?
That's where Apache Flink shines. Flink is a real-time stream processing engine that can handle high-volume, low-latency data streams with ease. It's like having a team of analysts who can work in parallel, constantly processing and analyzing the incoming data as it arrives. And the best part is, Flink is designed to be fault-tolerant, meaning that even if one of those analysts takes a break, the data processing continues without interruption.
Wow. So we've got Hadoop for storage and processing, Scoop and Flume for data ingestion, Spark and Flink for data processing. It's a pretty complex ecosystem. But I'm curious, once we've processed all this data, how do we actually find the insights hidden within it? I mean, it's one thing to have all this data neatly organized in a data lake, but it's another thing to actually make sense of it right.
You're absolutely right. And that's where data indexing and querying tools come into play. Think of it like this. You've got this vast library of information, but you need a way to quickly search for specific books or topics. That's where Elasticsearch comes in. Elasticsearch is a powerful search and analytics engine that allows you to perform complex queries on your data and get answers in real time. It's like having a super fast search engine for your data lake that can sift through billions of records in milliseconds.
So it's like having Google for your data lake. That's pretty amazing, but it's still a lot to take in. Building and managing a data lake sounds like a pretty daunting task. What are some of the things that companies need to keep in mind as they embark on this data lake journey?
That's a great question. One of the most important things is to have a clear understanding of what you want to achieve with a data lake. What specific business problems are you trying to solve? What kind of data do you need to collect? How will you process it? And who will be using it? It's not just about collecting as much data as possible. It's about being strategic and focused.
So it's about having a clear purpose, not just jumping on the data lake bandwagon because it's the latest buzzword. But I bet building a data lake is no walk in the park.
Yeah.
What are some of the pitfalls companies should watch out for?
You are absolutely right. Data lakes can be complex, and there are definitely some potential challenges to consider. One of the biggest is data governance. Who owns the data? How is it managed? What are the policies and procedures for ensuring data quality, security, and compliance?
Data governance sounds pretty important, but it also sounds a bit, well, dry.
What's fascinating here is that this data lake journey is more than just a technical undertaking, right? It requires a shift in mindset, a cultural change within an organization. You are spot on. A data lake is not just a technology project. It's a transformative initiative that requires collaboration across different teams and departments. Data scientists, engineers, business analysts, domain experts all need to work together to define the data strategy, design the data lake architecture, and ensure its successful implementation.
Okay, let's talk about the elephant in the room: cost. Building and maintaining a data lake can't be cheap, can it?
That's a valid concern. The cost of a data lake can vary depending on factors like the volume of data, the complexity of the architecture, and the choice of technologies. However, with the advent of cloud-based data lake solutions, the cost barrier to entry has significantly lowered. Cloud providers offer scalable and cost-effective infrastructure, making it easier for companies of all sizes to adopt data lakes.
So cloud computing is making data lakes more accessible even for smaller businesses.
Yeah.
But if we connect this to the bigger picture, what are some of the long-term benefits of investing in a data lake?
The benefits are multifaceted. Data lakes can help companies gain a deeper understanding of their customers, optimize operations, improve decision-making, and even create new products and services. They can also help companies become more data-driven, fostering a culture of innovation and agility.
Innovation and agility. Those are qualities any company would love to have. We've talked a lot about how businesses are using data lakes, but this raises an important question. What about individuals? How could an individual leverage the power of a data lake?
That's a thought-provoking question and one that we'll explore further after a short break. Stay tuned.
We're back, and before the break, we were talking about, individuals using data lakes. Could individuals, not just big companies, harness the power of a data lake? What are your thoughts on that?
Well, what's fascinating here is that the principles and technologies behind data lakes aren't exclusive to corporations. Individuals can absolutely adapt them for personal use. Picture a researcher using a data lake to analyze a massive collection of scientific papers, pulling insights from thousands of studies at once. Or a musician exploring different musical genres and influences, using a data lake to identify patterns and create something entirely new.
That's mind-blowing. I never thought of it that way. So it's about empowering individuals to become more data savvy, to make sense of the information overload we face every day.
Precisely. As data becomes increasingly central to our lives, equipping individuals with the tools to analyze and understand it can be truly transformative. Imagine being able to track your own health data, analyze your spending habits, or even map out your social network, using the principles of a data lake. The possibilities are endless.
So we're not just talking about business intelligence here, but personal intelligence as well. Data lakes can be a tool for self-discovery and personal growth. That's powerful stuff.
Absolutely. And as data lake technologies become more accessible and user-friendly, I think we'll see a surge in individual applications. Imagine open source data lake platforms that allow anyone to collect, analyze, and visualize data from their own lives and interests. It's a really exciting space to watch.
Speaking of exciting, we haven't even touched on regulatory compliance. I know it's not the most glamorous topic, but staying on the right side of the law is crucial for any organization, especially here in India with evolving data privacy regulations. Can data lakes help with that too?
Absolutely. In fact, data lakes can be a lifesaver when it comes to compliance. Think about the Personal Data Protection Bill in India. Organizations need to be able to demonstrate how they're handling sensitive data, where it's stored, how it's used, and who has access to it. Data lakes, with their ability to track data lineage, ensure data quality, and generate audit reports, can be incredibly valuable in meeting these requirements.
So data lakes are like the ultimate data management tool, not only helping organizations extract valuable insights, but also ensuring they're doing so responsibly and ethically. That's a win-win.
Exactly. It's about striking that balance between leveraging the power of data while respecting privacy and security concerns. Data lakes can be a powerful force for good, but it's up to us to use them responsibly.
Well, on that note, I think we've reached the end of our deep dive into the world of data lakes. From stopping cyber attacks to personalizing your shopping experience, from optimizing warehouse operations to empowering individuals with data-driven insights, we've explored a vast and fascinating landscape.
It's been a pleasure diving deep with you, and hopefully you've gained a new appreciation for the transformative potential of data lakes.
Absolutely. If you enjoyed this deep dive, be sure to like, share, and subscribe to our podcast for more insightful explorations of cutting-edge technologies and ideas. Until next time, keep diving deep.